We are live. Hello.
Amazing. I love it. Do you have like a start sound that you use the same way I do? So every time I start my streams.
Sound?
So I don't have a fixed one, but what happens is before I start recording, but after I start streaming, the screen is just black, and then I start testing my audio gear and then my video gear before I start recording. But
Oh no, hold on. I'm so sorry. Hold on. I accidentally muted for 1 second. Please continue. Sorry.
You're fine. No, so I have to do like an audio test before I start recording because sometimes it's broken.
Yeah.
But that means I have to start talking from a completely silent black stream. And so I need to find a way to not scare people when it starts streaming. And I've tried everything, and every time someone is like, I forgot I had this on in the background. I've tried just like soft whistling. I've tried just coming in with a soft radio voice. I've started songs. I started humming, but they are all disturbing.
You should start with the Windows XP startup sound.
Oh, that's good. That's good. I did do an audio start once where I just started playing Rick Astley. The problem was YouTube then immediately muted my sound because of copyright. Yep. It was rough.
Hello, Ewan Joe. Hello, RPC. Hello. Good evening. Happy Sunday.
Nice. I see people.
Yeah, people. I'd say let's just be a little silly for a few minutes and then start talking about the
that sounds perfect.
Stuff.
In fact, I need to figure out
how
to actually see your stream because I'm only seeing a square of Maya that's bubbling as you talk. I realized. So let me.
But I think you had a way of doing it. Right? Also, I feel like my camera's super overexposed. Let me turn down my face light a little. Oh, that's way better, I think. Yeah, that felt way overexposed. Okay, that's better.
I mean, it's easy enough. I can just open your stream. There we go.
Yeah. Hello, Unpronounceable. Hello, Martin. Hello, J-Bag. Hello, Bowman. Hello. Oh, my AC is finally kicking in. It feels so weird to use AC in September, but it was 29 degrees today here. So
I see. Yep. No, that seems perfectly reasonable. I mean, it feels weird. I have an AC in Norway, and that is not normal.
Yeah.
Norwegians do not normally have AC, but like these past few summers have been brutal, and so there hasn't really been an option.
Martin says, much respect for this guy here. Big up, John. Indeed. Big ups to John.
Big up. I'll take big ups. That's
Hello, Rampage. You're a beginner into Python. Any advice? Let's give Ram some advice about getting started in Python.
I feel like you're on the wrong stream if you want advice for getting started in Python. But I mean, we can try.
Yeah.
It feels like...
The first question I always like to ask in this situation is like, what made you choose specifically Python? Which is like, it's not like a judgmental question, but like surely there's something that made you like make that choice. So I'm just curious how you like ended up choosing that. Hello, Saruj. No, you can never be too old for big ups.
Yeah, it's funny. Like, I feel like I used to be very connected to internet lingo, and then over time, my up-to-dateness of internet lingo has sort of stayed, and then the internet has moved on without me. So now I try to like do inference as much as I can to like figure out what stuff means. You know, one day I'm gonna end up having like a conversation with ChatGPT or something and be like, can you explain this conversation to me? Because I don't know what any of it meant.
That's actually a really good idea, using basically like a Gen Z to Gen whatever translator.
Yeah, that's exactly what I need. I need a Gen Z agent and then a Gen Alpha agent, and then they can start talking to each other and try to explain to the old guy.
You want to build a career in AI and ML. Yeah, that makes sense. Python does tend to be, I think, the language that most people use there. Are you currently struggling with anything in particular in Python, or are you just kind of like, you know, wondering where to start? Also, Snakecase and Zlag, thank you for the follows. UK buildings are mostly brick with no insulation. I think they're here, like we tend to have brick buildings too, right? It's not like the US where we have lots of wooden buildings, right? I'm assuming over in Finland you have like brick buildings too.
Well, so I mean, in Norway, for example, and I assume Finland and Sweden and Iceland are all the same. The buildings are all built to be extremely well insulated, and that works well in the winter, of course. It also works well in the summer if you have an internal cooling mechanism. But if you don't, you just have to leave all the windows open, and that doesn't really work because it's hot outside. So it's just brutal.
That was also
the trick, I think, is to leave the windows open in the morning when it's cold and overnight, and then close them, and then hope that the cool air stays.
That was also a very nice and gentle way of letting me off the hook for saying Finland instead of Norway. My apologies.
No, you're fine. You're fine. See, you didn't even have to mention it. It was super sneaky. No one noticed.
But yeah, I feel like AC really comes into play. Like the miserable days are when it's like so warm at night that you can't like cool down your house like overnight. That's when you start needing AC, when it like starts affecting your sleep. That's where it's like, you know, really a big like bonus for life quality.
That's certainly true. Let's see. You want some word of direction or advice from two experienced programmers
we should look
about
for
how to get there?
We should look for two experienced
yeah, I know,
programmers.
right? I remember writing a program once. Yeah, I mean, I think it's really hard to give like general advice for how to get into programming, except use it to solve problems that you have. Yeah. Like this at least to me is like the primary way in which I learned programming. Is I had a bunch of things I wanted to write programs for, and so I used programming to solve those problems.
Yeah.
If you try to like follow like a well-developed class or something, that could also work. But in general, I find that I have much more enthusiasm and patience and memory for things that I build for myself for a reason than something that like I'm artificially pointed at and then I'm told go do this.
Yeah. Like the thing I can say to that is like if you're loving it, you're probably doing it right. Like if you're the thing that I like, the most important thing when learning, I would say, is to have fun. So if you are having fun with what you're doing it perfectly right, I would say. So just keep following like the way of the fun and like just learn whatever comes up, and I think you're gonna do great.
I think that's right.
Oh, Bound says
the version of left-right that is real-time safe for audio processing. Okay,
what do you mean by real-time safe?
Figure out. Yeah, I have a bunch of questions. I think one of my questions is, what do you mean by real-time? Like, what do you mean by real-time safe? The second is, why did you need to write a version of it rather than just building on top of it? And third, why do you need something like left-right in audio processing?
So the reader's real-time, I'm still curious what you actually mean by real-time save. It can always read, but the writer can block. Isn't that how it kind of works by how left-right already works?
Yeah, left-right already is the reader never blocks.
Left-right is so, do you want to talk about left-right, because this is like kind of how we initially met and what actually like kicked off this collaboration. It's like a wonderful library that John made over 5 years ago at this point that I have been using in my Rust project. It's like a really cool concurrency primitive, and I'll let John take it from here.
Yeah, so I'll give a little bit of backstory first because it might be useful. So during my PhD, I was building a high-performance database. It's basically a cache and a database sort of merged. And so it needs to have really fast reads because the whole point of a cache is that you have fast reads. And in order to do that, you need some kind of data structure that allows you to have highly scalable, highly parallel reads that don't block. And in trying to figure that out, you start out using a mutex and you go, well, a mutex is too slow. Then you start using a reader-writer lock. And then you realize that in order to take the read side of a reader-writer lock, you actually need to take a mutex for a very short period of time and then release it. And that works fine if you have generally slow operations. But in my case, like a cache lookup is really just a single hash map get. And a single hash map get is really, really, really fast. And so you ended up with that one mutex being the sort of the core blocking, the core performance bottleneck for the entire system. And so I started thinking, well, what kind of concurrency primitive could I use for something where I just want the reads to never block on each other, never block on anything. And I'm okay trading with slightly more stale reads. And what I ended up with was this data structure called left-right, which is essentially, in the case of using a hash map, you keep 2 copies of the map, left and right. All of the writes go to, let's say, the left side, the left map, and all the reads go to the right map. At some point, when the writer wants to expose all the changes they've made to the readers, the writer will take the sort of a single atomic pointer that points at one map or the other that the readers go through, and so it will flip that pointer to point to the map that it has just finished writing to, and then all the readers will start going there instead of going to the stale right side. And once all of the readers have moved over, then the writer starts using the right map and applies all the writes it did to the old left side to the right side, and then it continues to do further writes from there. And now all the readers are reading new, fresh results from that side, and the writer has a map that's up to date that they can write to without blocking on any readers. And the cool thing about this, of course, is that the readers never have to wait. The readers always just do an atomic read, and then they just access the hash map as usual. And then the writer is the one that has to block and wait and do all that annoying stuff, but that's fine. The writer is slow. The readers are the things that need to be fast. So that's left to right sort of in the nutshell, with the slight expansion that this was actually a data structure called EVMap, and then I generalized it to left-right to allow you to use other data structures than just hash maps as the left and right side. So you could have a left-right over B-tree maps or B-tree sets. You could have a left-right over your complete application state.
Hi.
Foreshadowing for maybe later, and so on.
I love the visualizations you did with your hands there, by the way, doing the left-right.
Left-right. It's so easy, right? Left-right, and then an atomic pointer at the bottom.
Yeah, it's perfect. Okay, so you said the reader can still allocate memory. You can only have one reader, but it doesn't allocate, so you can read on the audio thread. What do you mean by the reader can still allocate?
There's no allocation on the read side. So left-right has no allocation on the read side either. The read path is exclusively an atomic pointer read and nothing else. So
the guard, does that count as an allocation, or the...
The guard is not an allocation. So the only thing the readers do, and this is sort of going into the algorithm a little bit, but the writer needs a way to realize that all the readers have moved from the map that used to be the read map to the one that is now the read map, because it's only safer to modify the old read map when all the readers have moved.
Yeah.
And so there's a mechanism here where all of the readers keep a sort of generational counter for every read that they do, and the writer has to observe all readers tick over that counter once after doing the pointer swap, and then it knows that they've observed the pointer swap and therefore that they've moved. But that is an atomic U size per reader, and that one is allocated when you create the reader. So as long as you're reusing the reader, there are no additional allocations per read.
Riven asked if you would hire someone, what would you need in his portfolio? I feel like hiring is a whole thing, and hiring is hard. And some of the biggest issues in our field come from companies being, in my opinion, too lazy about hiring. Because you cannot hire someone using lead code. You cannot hire someone using I don't know, like their resume or degrees or whatever. In my opinion, what tells you a million times more than any of that is to just talk to them and like pair program with them for like 10 minutes. Just watching their process for 10 minutes, 20 minutes will give you so much information about how much they know, how they think about things, do they enjoy programming, and are they a good fit for what you do.
I think that's right. I mean, I've been involved in hiring in a few different companies now, and Amazon tends to lean slightly more on it's not quite lead code, but it's sort of, they give you a relatively standard set of problems, and then you have to code through them, and the other person looks at what you code. And then you get a bunch of behavioral interviews that have very little to do with code. So that's sort of the Amazon interviewing playbook. At the company I work at now, there's slightly more technical interviewing. And that one is a little more pair programming like the way you describe, where you take like an an interesting problem of some kind, like something that a programmer could be nerd sniped with, and then you sit down and try to pair program with them. The challenge, I think, is that whenever you sit in an interview context and you have to pair program, so many people freeze up because that they feel like they're under pressure, which they are, right? They're in an interview setting.
For sure.
And many people just don't perform under that kind of situation. And so for the people who are fine with that, then the interview tends to work just fine. But for those who don't, you can easily end up with someone who's a great programmer and great to work with, who just like can't quite handle that kind of situation, and then you need to find some other way to evaluate them or get them into their comfort zone.
I think the important thing there is to communicate, like be upfront about the fact, like, you know, just give them some like problem to work on and say, like, you know, it doesn't matter whether to get this done, you know, if this is like a programming language you've never seen before, it doesn't matter whether you've done this before. I just want to see. It's even better if it's like something they probably haven't seen before, because like I feel like what makes someone a good programmer is how do they approach a problem they haven't encountered before. Like how do they go about acquiring information, learning something new, and like it's not about like, you know, what do they get done, but just like how do they approach that kind of situation. And that's something that's almost impossible to determine with like, you know, some set challenge that they have to complete on their own, you know?
Yeah, I think part of the problem maybe with historical technical hiring has been that it's more about memorization, right? Like, have you seen this exact problem before?
Yeah.
Do you remember how to like rebalance a red-black tree or rotate a tree? And if so, then you're fine. Otherwise, you're in a world of pain. And you need to like try to solve these problems, algorithmic problems for first principles. What's more interesting to me are the kind of interviews where there's sort of like an open book exam where the expectation is not that you already know the solution, but is that we can see you work through how to figure out what the solution is. And that could even be looking it up online or working with like an agent or something to explain the solution to you. And then you need to figure out how to turn that into like actually good code.
Yeah. No, like an interview should never be like, you know, whiteboard or closed book. You need to know this by heart. Like, you know, things like lead code interviews and stuff, I often like to compare it to like IQ tests, you know, like it checks a very, very, very specific subset of like the field that is programming or like intelligence. But like, you know, just because someone has like a high or a low IQ, it doesn't mean they're smart or stupid overall. It just means they know how to do that one specific thing.
I think the other thing that's difficult, right, is for some people, it's a lot nicer to have things like a take-home. The problem with a take-home is because you don't get that pairing experience, you need to make it more extensive so you get more of a perspective on different ways of working, because you can't really prompt them as they go. The problem with the take-home is that as you make it more expensive, you're also taking up more and more of the candidate's time. So even though they might find it fun, it's not feasible for every company to give like a take-home that takes a day. Right? Like then suddenly now the interview loop is like way more intensive for the people applying when they don't even know whether they are going to get a job.
Exactly. And it's like not going to be paid or anything. It's just they have to give you that for free, basically.
Yep. To be clear, I wasn't trying to say that you're using it wrong. Like, I'm very happy to see that you're using it. That's exciting. It makes me happy when people are able to make use of it, even if it means you have to modify it. This is more almost like curiosity from my end, right? Like, if it's usable for audio processing, that's really cool. I wonder why you wouldn't be able to use it as is, so that I might improve it so that you could. But it was not intended as criticism.
Yeah, like the whole left-right thing was really cool because I remember like I was 5 years ago or something, you know, I was working on a distributed chat server for a company, and I don't even know how I ended up with FMAP because it was so long ago, but so I ended up like trying to use it for like my purposes, and I ended up like having to fork it, and then you came up with the idea of like, why don't I just make this more generic so you don't have to fork it, but you can just do your own thing with it basically. And like left-right was basically super useful for me because it meant I wasn't constrained to like just a map with like, you know, a certain set of values, but just I can now just use this kind of concurrency for whatever I need.
Yeah, I mean, the EV map was like solving the problem I had, which was even a little weird, right? So EV map was not quite just a hash map. It was technically a multi-valued hash bag. So it was like a map from keys to bags of values.
Yeah.
Where bags of values are a hash set, but it's not a set, it's a bag, so it has a count per element. And so, because that was exactly what I needed in my implementation, so that's just what I made EVMap. But clearly, that's like not the structure most people would want for the data structure. And so one of the nice properties of moving to left-right was that now you could actually write a straightforward hash map that uses left-right as well, rather than having to use my really weird version of a map.
Hired Beaver said young folks are cooked unless you're talented. I don't really believe in talent, to be honest. Like, I feel like for maybe there's like a small factor of talent, but for the most part, I think skill is really just a factor of how many hours you've put into it. Like, since, you know, we were talking about like skilled experienced programmers, like I have probably 50,000 hours of experience in programming at this point. I'm assuming you are somewhere around the same number, John, so it's just like,
I probably have 3 or 4 hours. I did some programming before the stream just to be prepared.
You just made left-right. That's like the only programming experience you have.
The
you made
only
left-right.
thing I've ever written was left-right.
But I think like talent is kind of like talent is almost like a way to disparage the amount of time people have put into things. Just like because like there's no talent doesn't even like factor in. Like the more time you spend on something, the better you're gonna be at it, you know. And maybe there's things. The only thing where I think talent comes into play is what do you enjoy. I feel like what you are kind of like wired to enjoy, that's what I would call talent, is like, is this something that you like doing? Because if you like doing it, you're gonna be like a million times more likely to succeed.
I think there's some amount of truth to that, because it's not just that you're then willing to spend more time, but it's also that sort of the reward system in your brain functions in favor of you learning it better and more, right? Because you want to build more things, so you want to get better, so you're willing to spend the time, not even willing, but maybe excited to spend the time to get better at the craft so you can build more cool things. And that I think gets perceived as talent, even if it's not clear that there's anything innate about the skill, but there might be something innate about the interest.
Yeah. How do you know yourself how good of a programmer you are? Just, it's not really something you measure, I would say. It's just kind of you encounter problems and you solve them, and it gets easier over time, I would say.
Well, so I was going to reply slightly differently, which is like, why does it matter? Right? Like, why does it matter how good of a programmer I think I am? I don't think that is actually important. I think what's important is, do you feel like you're able to solve the problems you want to be able to solve? And if you are, then great, you're good enough, right? And if you're not, then that means either you should grow your skills to be able to accomplish the things you want to, or if you feel like you don't want to grow those skills, then maybe your interests lie elsewhere, and you should find a slightly different topic maybe to focus on. And that could be a different topic within programming, right? It could be that you've been working on, I don't know, building websites, and you're like, this is not exciting me. Well, maybe programming concurrent data structures is your thing, like it was mine. And then just shift your focus there, and suddenly you'll find that you're way more excited about what you do. I saw also there was a comment here that someone said that their company pays people to take homes. This is really complicated when you hire internationally.
True, yeah.
So it's a great idea, very hard to accomplish in practice.
It also means you need to like do some like weeding out ahead of time using some kind of other method. Like I feel like that, just due to the nature of like it costing you money, you need to like have this be like a second or third round of interviews, because like you can't just have 10,000 people apply and then pay all of those people $1,000 for the interview, and suddenly you're out like $10 million, you know?
Yep. There's also something about like how much do you pay them is actually a little unclear.
Yeah.
Because one of the reasons you do interviews is to figure out how good someone is and how much you're willing to pay them to do work.
Yeah, that's true.
And so if you haven't done that yet, you don't know yet how much to pay them. And if you overpay them, then it just becomes everyone applies because they want to get paid. And if you underpay them, then it's not worth their time, so they might just turn down the interview. So it kind of just sucks all around.
Yeah. The way the company I've been working with for the past few years does it is that they have like an upfront, just kind of like a call where just like the CEO just kind of like, you know, basically uses like his intuition to see whether that person could be a good fit, maybe has them do like a few small challenges, and then it's just basically like a paid trial that just goes on for until basically one side knows, is this what we want or is this not what we want? And it's just
I think that works for a small company.
yeah, that definitely.
It
wouldn't
like
work for a
1,000
corporation.
employees,
No.
It's like unclear that
Yeah.
works, right?
It's like a 20-30 person company, so for
Yeah.
for them it works, but for like a big company it probably wouldn't work. Yeah.
Yeah. Baum, let's see. Oh, you only ever need one reader.
Oh, okay.
If you only need one reader, that's weird. I see. So if you have one reader, I don't think it actually reduces the complexity all that much. It just means that your list of readers will be of length 1.
Mm-hmm.
But the writer knows to stop after 1, so you're not really paying much of a cost to it. I would actually assume you're paying more of a cost by being on a fork of a library, because it means that as the library gets updated, you wouldn't get those
That's true.
changes. Now, left-right has not changed in a while because it seems to work pretty well. But like hypothetically, at least, it's nice to avoid being on a fork.
Mm-hmm. Is there like some other data structure that would maybe be better if you have single reader, single writer?
If you want readers to never block, then the closest I could imagine here is copy on write. So the intent of copy on write is the writer, if they detect that they want to modify one part of the data structure, they copy that entire part of the data structure and replace it. The problem is now you need every pointer in the data structure to be an atomic so that you can swap it with the write copy when the writer is done. And then you also need the coordination with the reader for figuring out when they're done with the old value so that you can collect it and drop it. And so this is a lot easier in runtime languages that have garbage collection because you know when the reader is no longer using it.
That's true. Yeah.
In a language like Rust or C, copy on write is a little harder to pull off in this way. So actually, I think this kind of setup of left-right is like probably the closest you get.
Okay.
The other thing you could have is like a reader-writer lock with a bias towards readers. But then the reader might still block if the writer is currently holding the lock.
Yeah. And I mean, even if you have like if you have a single reader, then you don't even like benefit. Then if you have a single reader, then an RW lock is basically the same thing as a mutex anyway, I think, because like you only have like basically like single reader, single writer is like something that's very hard to optimize for, because it's like you have like readers and writers in different camps, and if you have like multiple readers, it's relatively easy to optimize for, but like you still have like the upfront cost of having like a reader and a writer.
Yeah, someone mentioned arc make mute, and arc make mute is exactly the way that you do copy on write, but it's only half of the equation, because the other half is how do you make the new arc you've created be in the spot of the old arc in the pointer tree that the reader is reading from.
I don't actually know arc make mute. Do you want to look that up real quick? And because that's actually new to me.
So arc make mute is just if there is only one strong reference to the arc, then it turns the arc into a mutable reference.
Ah, okay.
If there are multiple strong references to the arc, then it clones the value, creates a new arc that only is yours, and then gives you a mutable reference to that.
Oh, I got it. Now I got to crop you a little bit because I have the documentation open and I didn't do the cropping yet. Let me just do a little bit of
nice.
This thing and put you here. A little less. There. What I think. There.
Alignment is hard.
Yeah. Oh, I have the chat. Oh no, the chat. That's okay. That's fine. Okay, so you said when there are no other so when there are no other arc pointers, it will. Oh, okay. So it needs to be cloned for that, basically.
Yep.
Oh, so it's basically just a clone on write. Okay. I see.
It's a clone on write. Yep.
Okay, cool. Learn something new.
Maybe, in fact, we could pull up the docs for left, right too, if we wanted to talk through some of the more like nuances of it.
Let's catch up on chat and then let's talk about left, right.
Sure.
You would argue that curiosity can be taught, though. I agree. Yeah, I think curiosity, like anything, is something that you need to learn. Like just openness to new experiences, basically.
Yeah, I don't think curiosity is something you're born with. I think it's something that is inspired into you, and I think it can be inspired into you later in life too. And I mean, whether that's it's not clear to me that it's taught as much as inspired, right? Like in the sense of like, I think the reason people get curious is because they see other people being curious and go, huh, like maybe I should also be curious about things. If you tell someone to be curious, it's not clear to me that it works. I think it has to be like a self-driven desire.
I feel like it's kind of almost the opposite in that we come into the world curious because like we need to learn everything, you know, like we come into the world knowing nothing, and like we have to like, you know, learn new things. And like I feel like loss of curiosity is almost like a stress response in that, like, you know, when you're under stress, then it's like, okay, you become so compelled to like just check off certain things in your life. Okay, like, okay, work is good. I'm good on like programming. I don't need to learn anything else there, so I can focus on the other things that are stressing me out. And like you should like work consciously to stave that off and like regain your curiosity, basically. And I guess in that way it can be taught that like someone else can help you regain that, basically.
Yeah, and I actually think one of the ways in which you can help people regain their curiosity is to show them cool things.
Yeah, absolutely.
Right? To like be the person who exposes them to something to be curious about.
Is there a trend to tailoring resumes these days? I feel like tailoring resumes is something you always had to do. Like the more your resume applies to a company, it's just part of the work you do of applying to a company, I would say, to make sure that you are what they are looking for, basically. So if you care about getting into a company, I would say always tailor your resume to the company.
Yeah, I think it really depends on how the company does hiring too. Because
Absolutely.
there are some companies that just look at your resume and if they decide based on the resume alone. And then there are some that do like a call screen plus the resume. And then you have the ones where you actually talk to a person from the very start. And it really depends. Like, I feel like how people react to resumes vary so much. Like where I work, for example, we tend to have more context of someone who applies than just the resume, because the resume, like, it's a list of things that the person has done, but it doesn't really tell us very much about what they are good at, what they're interested in. Like, you still need to go through the whole interview process. So it's mostly a screen for this person is unlikely to have anything to provide us with. But after that, I don't think it helps you choose. Like, I think it helps you choose a way, but not to choose.
Yeah. Let's see, is there anything else we need to catch up on? How locked down are the machines at your job? Well, I use my own machine because I'm a contractor. Do you get provided a machine, or are you also using your own hardware, John?
No, both at Amazon and where I work now, I was provided hardware.
Okay.
You get a choice of hardware. So currently, like, I get to choose macOS, Windows, or Linux boxes. But like, realistically, there's enough like locking down and security concerns that they want to have some amount of control over your machine. But it tends to be fairly like, I don't want to say trusted as maybe the wrong word. But there's a fair amount of like flexibility to configure your machine. Like, there's not a block on installing software, for example, or something like installing fonts. There's more of an audit than a premature block, if that makes sense. Like, they have, you know, system services that monitor everything that's installed and all the binaries and everything. So like, if you put something on there, then the company will know and be able to run analysis over it. But it's not like everything is blocked prematurely.
Props to your company for including Linux in that list, because I feel like in most companies you get like Windows or a Mac, and what is a Linux, you know? So props to them for having Linux too.
This was like a bit of a, I don't want to say a fight, but it was something where the default was Windows and Mac OS, and then there was a committed group of people at the company who went like, we need to make Linux also be an option because most of us are developers. And now it's like, that's one of the options you can choose.
Good.
It does come with some pain,
Oh.
right? Like, there's a bunch of stuff that just like, especially in the Microsoft sphere, that just like doesn't work well in Linux. And then now you need to deal with that yourself.
Yeah.
But for many, that's worth it.
Absolutely.
You can't change the homepage in your browser?
Oh, no.
That's awful.
I didn't even know there was like a thing that needed permissions. Because like it's just a user-specific setting, right?
Yeah,
Like it has to be like a
that's
super
terrible.
thin client what you have like connecting to like some... Like it's not even your own user account then, right? If you can't change your homepage. Yes, a recording of this will be on Twitch and I'm streaming it to YouTube too. So you can either like in these VODs you can download it and it'll be on YouTube like forever. So just...
They like that hiding the Booksmarts bar. That sounds like they've just, everything is read-only, right? Like
That's
all
true,
the
yeah.
settings are closed.
That's
Like,
crazy.
it feels very weird for someone in IT to go, you know what? Let's make sure we make the bookmark bar not hideable. Like that seems unlikely, right?
Yeah. Like we can't let them do that. That's way too risky. Yeah.
Yeah, that'd be crazy.
Mm-hmm.
Yeah, no, there's no way that was actually actively on the
Yeah, that's true. Yeah. Is Helsing remote friendly? That's a question for you, I think.
Yeah, I mean, I'm remote from Norway. Although given the kind of work that they do, we tend to require that people are within the same country as where we operate. So like being remote from, I don't know, Mumbai is going to be difficult, or from Sydney is going to be difficult. But as long as you're like in one of the countries that we operate, then yeah, you can be remote. Although there's sort of there's a caveat to this, and this applies more broadly than this company too, which is if you have a company that has offices for whatever reason, there will be people in those offices, and those people you don't really want to end up being alone, because that sucks. And so you want to have an incentive to people coming into the office to be with the people who have to be there because they're working on hardware or they need to take customer meetings, whatever it might be. Combined with the fact that I think there's a decent number of people, especially those more junior to the industry, where there's a huge amount of value in then them actually like sitting next to other developers and being able to go like, hey, do you know the answer to this? Or hey, I'm stuck. Or being able to like walk past interesting conversations. But that only, like if you tell the juniors they have to come in, you need to have people who are more experienced who are also there some of the time. Otherwise, it's just juniors like looking at each other's screens. And so there is a little bit of an incentive structure for like try to be in the office at least some of the time to encourage like that kind of growth for the people who either have to be there or should be there for their own career development. So it's sort of a hedged maybe.
For me, I feel like it was a bit different. Like even when I like first started like actually working in companies, I always wanted to like work remotely. But I feel like I also like went into it like having already like programmed a bunch like on my own. So like it just depends on like what experience level you're at. Are you like basically an intern who's like, you know, learning on the job, or are you like someone who's like experienced enough to be able to work on their own?
Yeah, and this is like totally true as well, that there are different profiles of developers, and there's some who deal much better with being remote than others. And there's some who have a lot more experience with it, even if they're more junior in their career. Maybe they've done a lot of open source work, and so all of their programming has been remote already. And so that tends to factor into whether it's reasonable to have someone be remote or partially remote, is like, to what extent do we think they're likely to succeed at that, right? Not just for our sake, but for their own sake as well. You don't really want to bring someone in and then set them up for failure.
Absolutely, yeah. Do we think there'll ever be a huge Java Spring type framework for Rust? I mean, there kind of is, I feel like, as close as we'll get to that with like Actix Web and Axum. Like they have dependency injection, they have like a bunch of like extractors from requests. I don't know like what specifically are we referring to that's like missing from those frameworks in Rust right now?
Well, I mean, I feel like Spring is a full application development framework. It's not just a sort of web server. Like it's not as tailored as something like Actix Web or Axum is. Maybe Bevy is something closer specifically for game development. right? Because it sort of tells you in a way how to structure your whole application. But I think having a sort of full application framework is a little antithetical maybe to how Rust programs tend to be structured. So I'm skeptical that we're going to see a like this is how your entire Rust application is structured, and it actually is used at large scale applications. That seems unlikely to me. I think we're more likely to see a kind of Python-like world where there are frameworks for certain kinds of applications, rather than the Java, like your entire thing is, be it Spring or in C++ something like Boost.
So it's something like, if we're talking like other web stuff, like Laravel for PHP or Rails for Ruby, something like that basically is...
Yeah, although even that we don't really have in the Rust world.
Oh yeah,
right?
of course.
We
I
don't
just
really
to
have
understand what
something
Spring is,
similar to-
basically.
Yeah, Spring is even more than that, because I think it also does things like GUI handling.
Oh, really? Okay.
Like it's the whole shebang.
Okay, okay.
But something like Rails is actually interesting. Whether we will see in Rust, I'm not entirely sure. I think like there's a world in which Rust grows something that looks or smells a little bit like Rails, but it's a lot of work to build, and we don't really have, I think, frameworks at quite that scale in Rust today, except maybe Bevy.
I think you're absolutely like right on point that it's like Rust is just not really the right language for that. In that I feel like Rust is a language. I mean, but before I started this project, I said like Rust is like the best language that you will probably never use, because like Rust is like, and what Rust does is incredible. Like the Rust compiler, Cargo, the borrow checker, it is all brilliant, but it's like it is still, and despite its popularity, it's still a very niche thing. Same with C++, because like Rust is something you use when you're either doing something that's very specific or where you absolutely need high performance. Otherwise, unless you specifically want to use it because you like enjoy it or something, you're better off using like TypeScript or Python or whatever, because like the innate development time is just higher in something like Rust, which is tailored towards doing it exactly the way you need it done because you have specific requirements.
Yeah, I think that's right. I think though that Rust is increasingly growing into the you can use it for almost anything kind of category. I think the big thing maybe that was holding it back was a lack of support crates, and that is slowly but surely getting better. Yeah, Pavex is a little bit like Spring, but it still is focused on writing a web server in a way that Spring is not.
There's a trade-off indeed. That's a little bit further back, just to make sure. A trade-off indeed that I feel that as a mentor to my juniors. As a senior, you can easily see your productivity being remote grow a lot. It's also really different person to person. Like some people just prefer being in the office because like either they don't have like a home office where they can focus, or they're just the kind of person who just work way better when they're like surrounded with people who keep them focused. So I think it's really, as a company, you either need to like choose one or specifically support both, in my opinion, because there's like just two counts of people.
Maybe the other thing I'll add is like the kind of stuff I do when I go into the office is very different from the kind of stuff that I do when I'm remote.
That's fair.
So if I go into the office, I definitely get less technical work done. But what I do get done a lot more is things like cross-team synchronization. Like I am much more efficient, like much higher throughput bandwidth communication for things like having a quick chat with someone about how to resolve a blocker, or you know, this team needs to talk to this team, and I can actually get all three of us in a room and we can hash it out really quick. Or just running into some of the new people we've hired and being able to give them a quick intro to how something works. Like all of that I'm much more efficient at when I am in person and can do it in 5 minutes, rather than like scheduling a 30-minute meeting or something that's remote. And so I think you're trading one thing for another when you go in person. And this is why I think the combination is actually pretty useful to do a little bit of both, is because when I'm remote, I get to do much more focused technical work, I think. And I get to do like some meetings I prefer taking remote, because like one-on-ones, for example, can be useful to have like we actually block off time and we sit down and do it. That can be harder to do in an office, depending on how many meeting rooms and stuff you have available. But then like I wouldn't give up the ability to see people in person relatively easily, because I think there's something that's super useful for even just building team culture, like being able to like meet up with a bunch of people after work and go to an escape room or something, like just to have a way to have, or a board game night, which is the thing I do a bunch, like that kind of stuff really helps build a feeling of familiarity with the people you work with in a way that being remote with them does not.
How often do you go into the office?
Well, so for me, it's a little complicated because I'm remote out of country. So our offices are in Munich, Berlin, Paris, London, Tallinn, and Warsaw. And so they're all like, I need to get on a plane and fly somewhere. I end up going into one of the offices maybe once a month. And that feels like roughly the right trade-off for me. If there was one in Oslo, I think I would come in, say, a day a week or something. But I don't think it's more often than that.
Didn't you say that, like, for your company, you can only, like, work in the same country? Didn't you say that before?
It's complicated if you want to be out of country.
Okay, so it's possible, but it's complicated, okay.
There are very few people who are remote from out of country, and I am one of them.
Okay.
And part of that is I have to travel a decent amount in order to make that possible.
And that makes you a contractor then, right? I'm assuming, like, you are... Because, like,
nope, I'm a full employee.
Oh, okay, so do they have, like, a subsidiary in your country then?
Yeah, exactly. They established a company in Norway to be able to employ me.
Aww, I love that.
Which is very, very nice of them, right? But like, that's the amount of, like... That's the bar for being able to hire someone, is like they have to be willing to start a company there.
Like it's either that or being a contractor, because like you cannot do cross-country employment, which is like just a general, like if anyone's like thinking about remote work in another country, that's like either you have to be a contractor or they have to have a company presence in your country, or there is like specifically like brokers which like facilitate that, which like they employ you and then contract out your services to that other
and the
company,
brokerages
basically.
Are like real awkward in a bunch of ways.
Oh,
like
yeah.
if you use something like remotely or something, there are a couple of them. And they're really weird because you end up being employed by a different company, and so it can be difficult if you want to get a mortgage because your employer is technically a proxy employer. It's a little bit of a mess. I was a contractor for this company until they established a company here, because it took a little while. And it was a little bit of a pain actually, but that's partially because of the industry as well. But like being a contractor means that you're not a full employee, right? So there's a bunch of stuff you're like kind of not supposed to get access to, or that's supposed to be restricted for you. But I was effectively a full-time employee, and so there were all these like weird exceptions that had to be made, and it was really just a pain for everyone. Not to mention you don't get a lot of benefits when you're a contractor, right? You have to provide your own benefits.
Yeah, you have to be paid more basically. Yeah.
Yep.
Do we think Rust will become more and more prevalent for embedded programming? I think so. I think Rust is an excellent fit for embedded programming. I think that's one of the things it's like really good for, in my opinion.
Yep.
Do you agree with that?
I agree with that. Yeah. Okay. And I also think that's where we've seen a lot of growth of Rust in the embedded space too. Right? Like the Rust embedded book and stuff is like growing specifically because people want to use Rust and are succeeding at using Rust in the embedded space.
RPC, are you I don't know what you mean by FUPS with NPM. Do you mean like are you asking whether the same thing that's been happening to NPM can happen to the Crate ecosystem, which is an interesting question. I don't know that. Do you know much about like security when it comes to crates, John? Like, because it's like, you know, there's been like the whole drama with like the viruses in NPM recently.
Yep. So, I mean, when I worked at Amazon, I basically owned the whole Rust build infrastructure internally, and that includes things like how do you build things from crates.io, and how do you pull them, and how do you, like, all of the stuff that's relevant to supply chain security for Rust. So I have a bunch of insights into there. In terms of whether it's a problem, whether the same thing is a problem in Rust as it is in NPM, the answer is kind of, because, so in Rust, the main problem is build scripts, because they run when you build, not when you run someone else's code. And so if someone injects a bad build script and you run cargo build and you have them as a dependency, then that build script runs, and it runs as you, because there's no built-in sandboxing for build scripts, which is, I think, one of the big things Rust is currently missing. And as a result, that code could do whatever it wants, including things like read your environment variables and like scan through your config directory in home and look for tokens. And then, you know, it could search for all, like the latest NPM hack was basically something that it did that. It found a bunch of tokens. It looked for all checkouts of NPM projects that were also published to NPM. And then it would walk all of them, inject itself into them,
Oh boy.
and then do a publish of them.
Oh boy.
Without doing a push, so that now anyone else who took dependencies on your projects would also be infected as well. So it became a sort of self-propagating worm. And I think you could do the same thing in Rust. There's nothing preventing you from doing so. I think build scripts are the biggest hole for this. There's something around custom Rust-up toolchains that can work even more scarily because they get run whenever you run any cargo command in that directory. But that one is a little harder to exploit, I think. And then there's also obviously, like, if someone writes a crate, they can just inject like bad code in that crate so that when you run a particular function, bad shit happens. But that requires you to actually run the code from the crate, whereas a build script sort of happens automatically.
It's a problem for open source in general, like open source in general has been incredibly based on trust. Like there's just been a lot of like everyone using each other's code, and in a lot of cases not doing a lot of auditing because it's just kind of it's been working well, but of course it's like an avenue for malicious actors to exploit, and as software development gets bigger, that's becoming more of a thing, and there's like, you know, as problems pop up, solutions will also start popping up, but we're currently in the problem phase.
Yeah, I mean, supply chain security in software is just really hard. Like, even if you ignore open source, but certainly with open source. And there's some really cool tools like Cargo Vet that tries to help with some of this, but like part of what we need here is sandbox builds, and then you get into like Nix land where you can build things through Nix's build jail, which helps. But even then, the jail is often not quite strong enough because it's not really built for security. It's built for reproducible builds. And for security, you need to assume that the code is malicious and not just like incorrect. And that is like a higher bar to clear. So this is just a very hard problem. And I think it's also really painful to solve because we've gotten so used to being able to trivially build the dependencies. But once you start wanting to sandbox them, it becomes a huge pain. Now a bunch of things that they used to be able to do just won't work anymore. And like they might be slower, like you won't be able to get their debug logs. Like there are all sorts of things that are really convenient about not sandboxing your builds that now suddenly hit you.
Since we're on the topic of concurrencies, they're pulling to add MLIR to the compiler chain to better support GPUs. I don't know that. Do you know anything about that, John?
I don't know of any change to the ability to target GPUs. I know there was some work to build a like a Rust 2 GPU compiler. So there's like a dialect of C basically that you can write to then compile to GPU code through CUDA or through OpenCL. And they're both like kind of awkward versions of C where like there are a bunch of things you can't do and you have some special functions available. And previously there wasn't really a way where you could write Rust code and have it compiled to the GPU. But there's been some efforts on developing that further recently so that you could write a sort of dialect simplified version of Rust and have it compiled to GPU kernels. I don't know how far that work has gotten though. Like I'm not on top of the latest developments there.
You just gotta lock the bookmarks bar for all developers to solve security. True.
It's true. That does solve all the problems. The bookmark bar is where the problem started.
Exactly. Do you think Rust is a good fit for defense technology?
Yeah, I mean, I think it's an obvious yes. Like if you compare to what the alternatives are, right? So it would be really nice to just be able to use a language where you like had no concurrency, you had no unsafe, you had no low-level control, but that's not a feasible choice, right? You need to be able to interact with hardware, you need to be able to use concurrency, you need to be able to use unsafe in order to do a bunch of like concurrency patterns that can't be statically checked. And so as a result, like you kind of need one of the modern languages. And if you're going to do embedded development, you're going to integrate with third-party things. So you need to do FFI. Then doing something that is a runtime is really painful. So that eliminates Go, Java, to some extent Swift. And so then you're not left with a lot of choices. You're left with like D, which no one uses, Zig, which is like a really good version of unsafe Rust, but it doesn't really give you any of the safe things from Rust, which is like most of your code is safe. And so you don't really want to give that up. Exactly. And then you have C, where you have like no expressibility in the type system whatsoever, and so you can't statically eliminate bugs. And then you have C++ that has types, but lets you very easily forget you have types, and as a result lets you shoot yourself in the foot really easily. Plus dependencies are a pain. So like out of those options, Rust seems like a really good one.
Absolutely.
There's an interesting question of whether like is there some theoretical language that could be better, and
I think so.
The
Absolutely.
answer could be yes to that. It's more that I think out of the options that we have today, Rust to me seems like not just the least worst option, but actually a quite good option.
Yeah, definitely.
And I think this applies beyond defense, right? It applies to things like the automotive industry, for example, or the space industry. Anywhere where you need to write software that ends up being safety critical, or where the consequences of getting things wrong are really high, or where you're willing to invest a lot up front to prevent problems later. Like I think in the finance industry, it's similar, where it's really costly to make a mistake, like actually costly.
Yeah, literally.
And then it's literally costly. And in that case, you want to put that additional time up front. I think it was Nico Matsakis who had this great quote of, and I think he had it from somewhere else, but I forget now, of like Rust gives you the headache up front. And I think it's a really good summary of the trade-off Rust forces you to make.
Yeah.
Right? It forces you to sit and think a bunch before you get to run your code. And very few other languages make you do that. There's like Ada is maybe the other thing people talk about here, but Ada is quite a pain to use. And it's not clear to me it's safer in at least some of the dimensions that Rust gives you safety.
I think what makes Rust so good, and like why I personally love it so much, is that it is so safe. It like has so much it checks at compile time, while at the same time being incredibly convenient to use. Like for what it is like it is not nearly
the
as
ergonomics
painful
are really good
as it like should be, all things considered. Like when you consider how much more safety it has, how much more type inference and everything it has, it's just not really all that much more work than something else that's as performant as it is.
I think it's actually one step further than that. It's not just that a lot of things are checked by compile time. One of the things I really like about Rust is that I can make more things be checked at compile time.
Yeah,
it's not just that the language has a bunch of built-in checks. It's that like the type system is expressive enough that I can add my own type checked invariants. And that gives me a lot of like, it makes my brain happy, but also it means I can write safer programs and I can write libraries that make it hard to make mistakes for others.
Macros are the same as build scripts. No, so macros are code generation. Build scripts are basically arbitrary code that's executed at build time. It is often used to generate other code or like do but it's really completely arbitrary code that's run at build time. So
yeah, but procedural macros are similar. So if someone writes procedural macros, they are run not quite as early as a build script does. Like a build script is run anytime you take a dependency. Procedural macros are only run if you use the procedural macro, but if you have it in your dependency tree, chances are it was run. And that also gets to do whatever it wants.
How do you handle this on a large scale setup? Like you set up a local forward of crates.io and desk can pull from it, and you own the update of local copy. I'll let you answer that one because you have a lot more experience with this.
I mean, I think this is partially a question to the Amazon side of things. Like how did Amazon do this? And the answer is partially that I can't tell you because
of course,
but it's partially that you end up keeping effectively a separate copy of the index that you have done a bunch of filtering to and analysis of. You control updates to that index. You have a sort of controlled ingest mechanism for bringing it up to date as the external index changes. You have really good provenance tracking and usage tracking of that index internally, so you know what's used. Anytime new things are used, you have a way to know about it, and you have a way to flag if something bad happens, and you do ongoing analysis of those in response to, like, imagine it's not sort of enough to filter when you ingress the index. You also need to proactively check any time like a new vulnerability is found in this old version of this library. Well, you've already brought it in, so now you need to find all the users of it and be able to like immediately flag them and tell upgrade your stuff. So there's a whole lot of machinery to this that's not just keep a copy, but it's also like ongoing analysis of all uses of everything in that copy.
Nico asks, how do you become very technically skilled at programming or at technical work if still in school or university? Honestly, just do it more, find the thing you enjoy the most and like just do that like as much as you can, as much as you want, it's the best thing to become skilled at anything is to just do it more. I don't think there's like really
I think that's true. I mean, we talked about this a little bit earlier, right? Of like have the interest so that you want to learn more, and then as a result you will spend more time and then you'll get better. I think there's a second part to it though, which is you can end up sort of hyper focusing on one particular area, and if you do, you can get really skilled at that area, but you don't really develop what people would see as technical expertise because it's very narrow but very deep. And so I do think there's some amount of try to identify areas that are slightly different that also interest you and go deep in those too, because then you end up with a broader knowledge base to build upon, rather than just saying I'm just going to be really good at this one thing and then just spend 50,000 hours on just the one topic. Try to broaden your horizons a little bit because it gives you a lot more breadth.
Yeah. As an engineer, that part of Rust is why you love it. You'd rather encourage thinking and having the headache up front. I think that just applies to like any kind of static checking in general. Like I never understand people where they go, oh, I don't like TypeScript. It makes me do so much work. It's so annoying. Like types are annoying. I just want to write the code and be able to just like. If you're like prototyping something, sure. If you're writing a quick script, then sure. But I feel like all of the work, it's like the same thing, like all of the work that's making you do is just saving you headaches down the line. And it just saves everyone so much time because like I feel like the hidden factor that people don't consider here is that when you have that amount of static checking, then anyone else who looks at that code, be it a code reviewer, be it someone else working on it, be it you in the future, there are so many things you don't have to think about, so many things that can't be wrong with a piece of code when you have the static checker running. It just reduces the complexity of the code to have static checking because you know that certain invariants will always be true, and that just makes it so much easier to reason about.
I think that's true, but I think there are some exceptions. So one of the ones I know the best is there was a really good article by Log Games about why they stopped using Rust for game development. So they were all in on Rust development, decided to like build a bunch of games in it, and they had this really long, well-written article that reasoned through the reasons why they are stopping using Rust.
Yeah.
And a lot of that came down to when you're doing game development, it's not that you don't have to think ahead, it's that changing your mind during development is the thing that makes a game good. It's being able to like experiment with like, what happens if I just completely change that thing or flip this thing on its head? And that can be really hard if you have a language that forces you into building a very strict architecture. And so they found that while Rust allowed them to build maybe more robust games, it did not allow them to build more fun games.
Yeah.
And they would rather optimize for the ability to make them fun and dynamic than for the robustness of it. Ideally, you get both, but they found that Rust ends up being too far on the side of making it not fun or not as fun as they could make it. And I think that's a compelling argument for like a case where maybe you don't use Rust there in that kind of game development, for example.
It's also like, like you mentioned earlier, like, there's certain use cases where it's like really costly to make a mistake in a game, if your game has a bug, you know, like, okay, you push a patch, you fix it, and that, like, it's just not that, it's maybe not important that, like, sure, the performance matters, but, like, the cost for making mistakes is relatively low. And I find it reminiscent of, I don't know whether you had it on your radar. Did you see that when, like, during development of Svelte, they decided to stop using TypeScript internally in Svelte, and, like, said that they would just, like, use JSDoc. And the reason they gave for that was that you know, like, Rich Harris, he basically said that, you know, TypeScript is great, you should all keep using it, but we're not going to use it for internal Svelte development, because it's just it is for making the kind of library that Svelte is. If you don't know it, it's like a JavaScript front-end framework. It's just it is the specific kind of use case where you don't want to be constrained like that, because you're doing, like, a lot of dynamic things, a lot of, like, things that are you're optimizing certain ways that TypeScript can't understand, and it's just not worth the cost of making the compiler understand it.
I think the equivalent here maybe is if you write a library that is basically all unsafe code, then there's an argument that that library should maybe be written in Zig, for example, rather than in Rust. Because then you're picking a language that is better suited for that specific task, where you're only really using the parts of the language that are more painful to use in Rust. And, like, you can look at this with Tiger Beetle, for example, where they're not using Rust for their development; they're using Zig. And there's a bunch of reasons why they made that choice, and they've articulated them a couple of different times. And I think it's an interesting argument where they were basically like, we're building a very specialized protocol. It's not a general purpose database. It is aimed to build at one specific type of table with exactly this schema, and it has to enforce the invariant. Like, it's basically a ledger, so it only has, like, account balances and plus and minus, where it always has to add up to 0. And it turns out you can build a distributed system on top of this, because where you make very different trade-offs than standard distributed protocols, because you know exactly what the nature of the data is. You know all the invariants, you control all the inputs, you know the format of everything. And so they were basically like, we are going to do a bunch of optimization for things like, we will never dynamically allocate memory, ever. And that's really annoying to do in Rust.
Yeah.
Right? But if it is the kind of decision you might make if you want an extremely robust database that will never, for example, crash because of out of memory. But for that, like, that feels like the kind of thing where you would end up writing basically a program that is all unsafe Rust, or a lot of it would be unsafe Rust. And at that point, maybe you just pick a language that's better suited for that kind of task. But I do think that those are the exception and not the rule.
Absolutely, absolutely. And there's also, like, just generally an argument to be made that, like, if a project gets big enough or specific enough, you might want to use more than one programming language. Even just, like, you know, sometimes when I work on, like, my chat thing, people ask me, like, why are you not using Rust for the front end? Something like, I forget the names of the front end, the web front end things in Rust, but it's like, I think it is just not the right tool for that job. Like, sure, you can do it, but it's, like, so much easier to do something like that with TypeScript, and there's nothing wrong with using multiple languages, multiple frameworks, as long as you can get them to interop with each other.
Yep. I mean, we've seen I think a really good example of this in the Python ecosystem, right? Where Python has started now adopting Rust for a lot of their native modules rather than using C, and I think that's been a huge boon to the Python community, because now you get safer bindings, they are easier to build, especially when you have dependencies, and, you know, less painful because you don't have to write C++ code. But that's more of a personal take, right? But we've generally seen that they've made the choice, and arguably back in the day when they were written in C and C++ too, you know, there are some things you don't write in Python. You write them in a different language and you integrate them with Python. And I think that's a perfectly reasonable choice.
Alice says tomorrow I'm giving a talk to a bunch of C developers, and I'm starting it with a section on why Rust, so I'm assuming your talk is about Rust. The quote from Nico, and also the one about adding more things to check you might include it. Any other good ones? Well, what is your take on why Rust, John?
You know, I think I'm going to try to split this into 3 answers and then see if I get to 3.
Hell yeah.
I think the first of them is dependency management. I think this is an obvious one, but like if you're specifically comparing to C and C++, the story for dependency management in C and C++ sucks. Like, it's not just that it's kind of bad, it is genuinely terrible. But it's terrible not just in the sense of like the ergonomics are bad, but also from a security perspective. Like, your supply chain security story becomes a lot harder if all of your dependency management is ad hoc. And so you really want to have a strong ability to know how dependencies are brought in, and having a build system that's used universally throughout that entire stack helps enormously with that. So I think dependency management build system is one. I think the second one is the one I said earlier, that it lets you enforce additional invariants. And this is, I think, maybe the thing I use the most in Rust, is I very often want to write code that I can't myself misuse, because I know that future me is stupid.
Yeah.
I also know the past me is stupid, but right now me is pretty smart, right? So what I will do is I will be like, I've thought a bunch about what exactly this type needs to be able to do, and so I'm going to write code that makes it impossible to use it in any other way.
Yeah.
So that future me doesn't have to relearn everything that I'm currently holding in my context. They can just use the API, and the only thing it allows you to do are the things that are correct.
That's also what I was talking about earlier, if I can interrupt for a moment, is like the thing that like it makes your code so much easier to understand if it has those kind of safety guarantees, if it has like, if it is written in a way that's like, you know, that only the correct way can be true, it means you have so much less to think about, you know, and I think so it's always worth it to have like that upfront cost of writing it like that, is that you just, any future work you do on it, or any future work that anyone else does on it, even if it's just code review, gets so much simpler. Like, it's like why I always love, no matter the programming language, having like linters, because like it makes code review so much simpler. You like, if you know that the types check pass, the lints pass, then there's so much less you need to be on the lookout for, because a certain standard of quality and of correctness is guaranteed.
Yeah, I think, you know, there's an extension to this argument, which is when you're working in C, you tend to, it sort of depends on whether you're talking to C or C++ developers, because the story is slightly different. Yeah. But like, okay, there's a library called NNG, which is a spin-off of NanoMessage, which is a spin-off of 0MQ. For those who know any of these names, they're all roughly the same, but NNG is the latest in the series. And NNG is implemented purely in C, so that it should be easier to link with from any language and whatnot. NNG implements a bunch of different network protocols, like pub/sub, request response, peering, pipelines like push-pull, survey respond, like a bunch of different protocols. And in the C library, the documentation has a lot of statements like, you are not allowed to do this operation on a socket of this type.
Yeah.
Like, if you open a network socket and you say that it is a publish socket, you are not allowed to read from it. But there's nothing in the API that makes it so that you cannot. Yeah. It's just that if you do, you'll get an error back that says this operation was illegal. And that to me is like, it's like dissatisfying on some very deep level of like, it shouldn't be possible for me to call functions that it's not legal for me to call.
Exactly.
And so I've started writing, there is a library that writes Rust bindings around NNG, but it replicates much of the same behavior of, it basically keeps the same types and keeps the same methods, but it makes them safe to call from Rust. But what I really want is one that is much stricter about only letting you do specifically the things you're allowed to do. And there aren't that many languages that allow you to write code like that. Like, there's Haskell, which has very strong typing of this kind. There's like the proof-oriented languages like Coq, which has now been renamed to something else that doesn't sound like Coq.
I was gonna say.
Yeah, there's like F star and Daphne. Like, there's a bunch of like proof languages. And then there's Rust. And like, apart from those, most languages wouldn't let you express this kind of limitation.
Absolutely.
Except in like very annoying ways where you have like a bajillion different types and you need to like implement the method on all of the different types because they're different. There's no generics, you can't combine them, there are no traits and whatnot. And so like, if you want the ability to enforce more things at compile time, you don't have many choices unless your choice is Haskell, which I don't think it is, right? And so that leads you to Rust. And then I think the third argument is a little bit of a softer one maybe, which is there is a lot of excitement for Rust right now. Like if you try to hire C and C++ developers, you will generally not find that they are very excited about writing C or C++.
Yeah, true.
They're also not necessarily very excited about the language. Like it's unclear that they will have a deep interest in the language or why things work the way they do or the most recent developments in it, because C++ is a language that develops slowly. It's also seen as one that has a lot of historical baggage and a lot of footguns that just have to continue to exist because the language has no good mechanism for evolving and has to maintain backwards compatibility to a lot of ancient stuff. And so if you want the ability to hire people where there's some enthusiasm behind it. Like people will be excited when you say that you are using Rust in a way that people are not excited when a company says, yeah, we're hiring C++ developers. That feels like a standard reply rather than an exciting opportunity. And that does make a difference. Now, there are fewer Rust programmers, so like it will be a little harder to find candidates in the first place, but I think the ones that you find will be more excited. The prospect of working at a company that uses Rust, I think, is more enticing to people than one that does not.
The thing you said about like wanting to express things in a way that's like, you know, that's like that is more expressive and descriptive, basically. I think that applies a lot to comments as well, and I know a lot of people will disagree with me on this, but I am generally of the opinion that most of the time when you find yourself wanting to leave comments on a code, it is a sign that you should probably structure your code differently in a way to make it more understandable by itself. I know a lot of people will disagree with this, but it's like, I would argue that you should like name your functions in a way, name your inputs and outputs in a way that it's like clear what it does, and just generally structure your code in a way that the only comments you really have to leave are when you are forced by circumstances that are out of your control to write code that is less than ideal.
I don't disagree with you, but I have a slightly different take. I have a really long blog post about this that I've wanted to publish for like a year, and I just need to get my shit together and actually do it. But one of the starting points of this blog post is in my editor, in my theme for my editor, comments are bright orange. Comments should never be like a shade of black that's like almost impossible to read on screen. They should be in your face, because if they are useful, they're important. And if they are not useful, you should remove them to remove the visual noise. And I think like this incentivizes you to write comments where if you're going to put it there, it better be useful because it's going to be in everyone's faces. And so I tend to use comments, I think, for like maybe 3 or 4 different things. I use it for to-dos. I use it for non-obvious implications of code, especially things like where there are interactions between this part of the code and some code over there. And so that's like, you need to know about this code over here from here. And the only way to do that is with a comment.
Absolutely.
I think the third one is around explaining invariants that are outside the scope of the current code. So this can be, especially for unsafe code, right? You write safety comments because you know that this field is safe to access because all the other places where you access it cannot possibly have happened at the same time as where you are right now.
It's kind of the same as the second point, even like, you know, another piece of code you need to like look at or know about to like understand the full scope of this
very
code.
Similar. And then I think the last one is trying to explain why something isn't there. This one is kind of counterintuitive, but there are times when your code specifically doesn't include some snippet of code that people who read the code carefully would expect to be there. Like imagine you have like 3 functions that do almost the same thing, and one of them is like missing one part of the code, but it's missing on purpose because it does not work or cannot be done for this particular execution. If you don't leave a comment there, then someone will miss that fact and they will inject the code and then go through a learning experience.
Yeah.
Right? And so putting that comment in there preempts people from making the same mistake. This can also be like, if code looks like it's suboptimal, you might document why it's still done this way. Because the other way, like, will not compile, and I found out by spending like 3 days on solving
I
this
already
problem.
did this. You don't have to go down the same path. Exactly.
Yes.
Yeah. I love the phrasing of like making comments bright orange because they should be there for a reason. I like that.
Yes.
Yeah.
Yeah, and this is also why I hate documentation comments that are like, the foobar function foos a bar, and you're like,
increment
okay, great, remove, please remove that comment. It is stupid.
Yeah, and it's like, you should really think about, like, when you're leaving a comment, is like, why are you doing, like, could you express what you were about to write in as a comment? Like, is it already expressed in the code, or could you rewrite your code to express it better? Like, because like you should never really have to read the body of a function to know what it does. Like, you have the name of the function, the inputs, their types, and the output, the type. That should tell you everything you need to know. That's not specifically advocating for like keeping functions as small as possible. I don't agree with that kind of clean code stuff.
No, I don't either.
Okay, good. I disagree with a lot of that. So I don't think there's like, one specific way that code has to be written, or like, specific like, patterns that every code needs to follow. Okay.
I agree with that, but there was one thing I have a particular weakness for, which is something called literate programming, which comes from, I think, Donald Knuth. That's all about writing code such that it reads roughly like prose. And so you shouldn't split things into functions if it's easier to read as linear code. You should leave comments that tie the story together between the blocks of code that you have. So you should explain why you have to do something, for example, in a certain order, but you should not necessarily explain what the code is doing unless it's highly non-obvious.
Yeah.
And so the whole idea of literate programming is I should be able to read your function top to bottom as though it were an essay.
I think the reason that like internally I find myself pushing back against that is because I've been forced to write like a lot of like Ruby and Rails, and they take that way too far because they end up doing like so much. Basically, they like hyper focus on it, on like making code read like English, that it like starts obfuscating a lot of what's actually happening. Like they basically they want code to
go too far.
They want the code to just read like, okay, do the thing, and then happens to call one function, the space happens to do another thing. There's like something that calls like 3 hooks behind the scenes, and it's like, that's just, it should still be all there. You shouldn't have to like look for the code. It should all be like visible to you.
I think 5G Technician made a good comment in the chat here that there is a category I missed, which are the comments about how you apologize for the code that the person's about to read. Yeah. I definitely have some of those.
Let's catch up and chat a little bit. TypeScript is just a bad contraption for a bad language. I personally think TypeScript is exactly what it needs to be. I think JavaScript and TypeScript gets too bad of names because like obviously there's like a lot of like legacy stuff in there, and they are working on improving it, but like it's for something like the web, it makes perfect sense that there's like something that's dynamic and simple and just upfront, and then TypeScript takes that language and makes it more strongly typed while still preserving the like what JavaScript ultimately is. So I think like if you're doing
incrementally adding types to language is really hard. Yeah. Like PHP tried to do it, Python tried to do it, TypeScript tried to do it, and in every case it comes with a bunch of shortcomings, but it is better than having no types.
Absolutely. And I think TypeScript is actually really good. Like I enjoy it. Like it is actually the JavaScript is the language that I recommend for basically everyone for basically everything. Like unless you're doing something specific where like there is a language that is a better fit for it, I think JavaScript is the best general purpose language we have right now.
Unpronounceable wrote, I actually appreciate having a very non-checking low-level API that exposes the actual primitives the library is dealing with. having a higher level of abstraction is useful too, but they sometimes have a bad habit of not supporting some of the niche use cases I need. I think that's totally true. And I think it's actually up to library authors to think through how their thing is likely to be used. Like if you think about something like left-right tries to expose very low-level APIs for allowing you to construct a data structure. It's not intending to be a high-level library. It tries to give you like relatively unsafe sharp tools. But then you also have something like, it's a good example of this, like...
I mean, just FMAP, right? That's the higher level abstraction on top of it.
EVMAP would be a higher level abstraction, but I'm thinking something even higher, like Inferno, which is like the port of FlameGraph to Rust. So there's no real reason to give the low-level bits of the library. Ultimately, you're taking in a bunch of like samples and then you're turning it into an SVG. Like the lower level things would not help you. They would only make the API more painful to use.
Yeah, true.
But like if we go back to the NNG example, actually, like I'm very happy that the author of the NNG C library exposed very low level things. That's what allowed me to write an ergonomic Rust library on top of it, is because I could plug into all the things and make it do the right thing in the right order. So I'm fully on board with some libraries being better suited for low-level things.
Yeah,
in fact,
absolutely.
I would argue you very often want to have two libraries. You want to have one that's the low-level one and one that's like a type-safe binding on top of it. But whether you need both of those really depends on the library in question.
It's the same with like how there's like, you know, a place for both like JavaScript and Rust, you know, like for most cases you just want JavaScript, which is just like, you know, the simple high level thing, which just like makes it easy to do like most things. But when you want to really like when you have like specific use cases, then you want to go down to the low level.
Yep.
Heretical Programming asked, what are the profitable to implement static checks? What do you mean by profitable? All of them probably. I guess it depends on how you define profitable.
Yes, it's profitable.
How do your work habits look like? When do your days normally start? How long do you work each day? Work during weekends? I kind of just work whenever. Like I have like my streaming schedule, but if I didn't have my streaming schedule, I would just work completely whenever. What about you?
Well, I mean, I have a normal full-time job, and so that dictates at least some of my schedule. Realistically, the company is fairly flexible about how I work. There's an expectation that I work roughly that number of hours over the course of a month. But it's not really tracked on like a day-to-day basis. So there'll be some days where I don't work for a few hours here and there, and then some other days where I'll make up for like those days where I did work, or sometimes I'll work a lot one week because I have a deadline or something, and then I will correspondingly work less the following week or a couple of weeks later, or take a day or whatever it might be. So it's fairly flexible in that regard, but normally, you know, when you work in a team with a lot of other people, realistically, you have to be online when they are online at least some of the time. So I tend to organize my day roughly around the standard sort of 9-to-5 schedule, but shifting that as fits with my day and taking gaps when that's appropriate. And you know, like I did a bunch of programming yesterday because I was working on these energy bindings, which I'm doing for work, and so I'm like, this is fun, I want to do more of it. And so I worked them on a Saturday because it's fun.
Totem asked, am I the only one that still believes there will be a deep refactoring of the structure of Rust as a language? I don't think so. I think there might be like a successor to Rust, but a Rust with its stability guarantees I don't think can be changed fundamentally. So I think Rust is going to maybe like get a few new features, but like the core of Rust is going to stay what it is. I think just due to its stability guarantees, it has to.
Yeah, I think it's pretty unlikely that we see like a Rust 2.0 that's fundamentally different. The cost is too high. You know, there's a chance that eventually the language has to break because additions don't carry you any further, but I find it unlikely. Like if we would have seen that, I actually would have suspected we would have seen it already. Like for example, in things like part of the reason why we need pin is because of some earlier semantic choices that Rust made before stabilizing 1.0. Technically we should probably have pin be passed in the drop trait, but we can't change the drop trait, and we can't change it as an addition boundary. So there's like a bunch of reasons, like there are already a bunch of really good motivations for breaking backwards compatibility.
Yeah.
And they didn't do it because it is too costly. And so if they didn't do it for that, I have a hard time seeing what would be the reason to do it later, especially given that additions give you a fair amount of flexibility to like adjusting the language in most of the ways that matter.
Raises that on the topic of comments. Writing examples in comments is also a good idea. Yeah, I agree. So usage examples are probably a good thing for, but that's like, that's more like function level comments and like, something where like, on the level of like the body of the function. So like if you are documenting your API, then usage examples are a good example for something you would rightfully leave a comment for, I would say, yeah.
Yeah, I mean that's more like doc tests though, but arguably doc tests are comments.
Yeah.
I tend to kind of separate like documentation from comments because even though they are both comments in the code, they serve a very different purpose.
That's true. That's true. See what else is there? Do we do side projects or just work? For me, for the longest time up until recently, I've only been doing work, and it's been like a kind of a personal change that I started doing side projects again, because like I don't know, I think just because like I needed a break from web dev, and so that's why I started doing like my own stuff again. But for like a few years, I kind of just had been working only on work projects because it was like interesting enough by itself. What about you, John? Are you doing mostly work, or are you doing your own projects too these days?
It's a little bit of a mix. So the problem I had for a while was that I just did not have the time for any one of my side projects because I had picked up too many. Like I have this problem where I have a long list of side projects I've already taken on. Some of them are programming related, some of them are not. And then I also have a long list of other things that I want to do as side projects. And as a result, I feel like I stretch my time between all of them and I don't have enough time for any of them. And then I realized I hadn't played a video game in like a year and a half. So I was like, something's got to change.
Yeah.
And so I've actually narrowed down the amount of side projects that I do. So for example, the IMAP crate, I'm actively looking to hand over the ownership of, and I have some people that are like looking to step up as maintainers, but it's the kind of thing where like some of the things that I'm not really using myself anymore, and I know that they deserve more attention than I'm giving them, I try to give up. But it's not like I don't have any side projects I work on anymore, right? Like I still have, We Were Wondering, for example, which is like this online Q&A thing that I use for some of my live streams. I still maintain things like the HAR histogram crate or the Fantaccini crate. So there are a bunch of things that I maintain, but definitely less actively than I used to, I think. So I tend to sort of try to find side projects and then try to complete them to the extent that I can.
Yeah.
Left-right is arguably an example, right? Like there hasn't really been a need for a change in left-right in quite some time because it does its job.
Yeah.
And I like building libraries like that. Like I think being the maintainer of something like Bevy or like Axum, like something big that has to evolve over time, is just not what I enjoy doing either.
I get that.
I like to build really useful primitives.
Nico asks, how much do you think school taught you versus your personal projects? I will admit I have a very, very low opinion of the current state of programming education. I think universities especially do such a poor job of like educating people with just focusing on all of the wrong things, and like the biggest issue is that, and like this is like, some like condensing a topic into probably a way too small sentence here, but I feel like the biggest issue is that we are teaching programming, software development, not as a trade, but as something that's academic. And I think that we should focus way more on the practice of it and keep the computer science to the people who were interested in the computer science. Like, I think computer science and programming are two very different things.
Yeah, I get asked, like, especially by colleagues who maybe only did a bachelor's, or, you know, maybe did no formal education at all apart from high school and just have been programming professionally ever since. And they're like, should I go back to school? Like, is there a lot I'm missing out on? I feel like I don't have the computer science background. And they, you know, I think the answer I usually give is what studying gives you, what being a student gives you, is time to explore. At least that's what I found to be the most useful. Like, it gives you the sort of time and freedom to try a bunch of different things in a way that's hard to do when you're working. But I don't think they make you better, right? They just give you the opportunity to do more of that exploration. If you feel like in your professional career, you've gotten the experience you want in the areas that you want, that's what matters. It's not like you would become a better programmer by doing the Bachelor in Computer Science. Like, I don't think that's true. I also think there's some amount of, especially at the bachelor level, the computer science curriculum tends to be like, it tends to cover a variety of topics and give you basic information about them. Things like, what is object-oriented programming? What is a function? How does the stack work? What is the database? What is XML? Like those kinds of things. And maybe some rudimentary things about data structures, like what is a hash map? What is a set? But I think those are things you pick up pretty rapidly professionally anyway, if you need to use them. And if you don't need to use them, then it's fine that you don't know them. The only exception, I think, to this, or the only caveat to this, is sometimes it's really useful to have had exposure to certain ideas before you need them. Because it can be really hard to identify, oh, I could use a try here, if you have never seen a try and don't know what it is, right? So that's the kind of thing where you could read up on what a try is if someone told you to use it, but you wouldn't realize you needed to use it if you haven't had exposure to it. So there are some of those where I think it's useful to like get some of the nuggets that come out of it, but I think you can get those fairly easily by being a little bit proactive about your learning on the side from your professional career. Doing a little bit of reading on like data structures, algorithms, databases, being a little curious about the field gets you pretty far here. I don't think you need to specifically be a student for it.
I think a really good example there is, like, I think it is extremely beneficial to know what kind of data structures exist. It is extremely niche to the point of almost never being useful to know how to implement those data structures. So it's, and I feel like that's like something that gets way too much focus in, like, oh, learn how to write quicksort, learn how to implement a, I don't know, binary tree from scratch, and it's like, you're 99.99% of the time never going to do that. You're not going to want to do that because you just want to use whatever's built into your language framework, whatever, because it's going to be better than what you can write, and it's going to be less overhead to maintain than what you can write.
Yeah, but I think this actually partially relates to, if the world is C and C++, then you do actually need to implement a bunch of those things yourself, because how are you going to get dependencies? Wow. But sort of putting that aside, right? Like, I do think there's a lot of historical stuff here of like, traditionally you had to know a bunch of these things. That's no longer really true. And I think much of the education hasn't kept up, at least at the sort of introductory level. Like when you get to like the PhD level, the kind of things you study are more like distributed algorithms or database implementations. Like then it comes back to being useful again, because you are actually the one implementing these things. But I think what we're really missing is like, there really should be two domains. Like there should be computer science and programming. Exactly. And it feels like those are different. And programming to me feels more like carpentry. Like it feels more like a
trade.
It's a trade. It's a vocational study rather than a theoretical exercise.
I completely agree. And like the problem is that, like, you know, like I said earlier, like companies are lazy about hiring, and they're like, well, so many companies will be like, well, if you don't have a master's degree, then like when you think about it, it is like such a crazy system where like you have to get a master's degree in an academic field that is only loosely related to the job you do, to be able to work at a junior level. Like, you spend years going to university to get a master's degree, so you are barely qualified to work at a junior position. It is just crazy.
Yep. I think, though, the one other bit I'll add here is, like, there are a lot of benefits to being a student that are separate from the thing you're studying.
Absolutely, yeah.
Right? Like, being in an environment where you get exposed to a lot of other people, a lot of other ideas, you get time and flexibility that you don't have when you're working. Like, those things matter a lot too, but they're not, like, worth it on their own in a way. Or maybe they are, but it's only for a limited amount of time.
For sure. You want computer science degrees to be more about computer science than programming. Yeah, it goes both ways. Like, you know, people who are interested in, like, the actual computer science probably don't want to learn the trade of programming nearly as much. They just want to, like, you know, they're interested about, like, the design, the architecture behind it, and there's surely some programming in there too, but they're not going to be interested in web dev or something like that, probably. And so treating the two separately makes a lot of sense.
That's interesting. I didn't know this. So Sondriel says in chat that programming is like carpentry in Norway now at a high school level.
Oh,
that
good.
You have to do an apprenticeship.
Nice,
which, like,
that's perfect.
Makes a lot of sense to me. Like, that feels like the kind of way you have to study it. Or that feels like the way to study programming, but not computer science, right? So it depends on whether you want to do the split. I also think, you know, that there's a bunch of things that they don't teach you in computer science studies that's also not really about programming at all, but are more about like how to operate a computer, right? Like, this feels like a whole field we just kind of miss. So this is why I ran a class at MIT a few years ago that was called The Missing Semester, which is all about teaching people, like, how to use the command line. Like, what is CI? How do you write a YAML file? Like, how do you configure your editor? Those kinds of things that are just like, you're just expected. How does Git work? Those things you're kind of just expected to figure out as you go. Even though it's like they are the tools of the trade that we're not teaching people beyond just, like, programming is obviously a tool of the trade, but so are all these other things. And those you're just there is no part of the curriculum that teaches these, and it's a real shame because they are critical to being able to execute on these kinds of jobs.
Nico asks, assuming you have the skill, how would you get a job without a relevant or no degree? Well, that's kind of the point, you know, like, that's the... What John and I are talking about is kind of how things should be. The problem is that's, like, you know, not really how they are, and, like, the truth of the matter is, like, you know, you gotta play the game. You know, like, if you are surrounded by companies who... Like, if you live in a country where degrees are valued super highly, then... Even if it isn't, like, you know, going to, like, even if you're going to have to supplement it with your own learning, then you gotta get a degree. You know, like, that's just how it is. Like, what we're saying is more, that's not how it should be. You know, you shouldn't put people who just want to, like, you know, write code, make software, you shouldn't put those people through 5 years of theoretical learning. That's kind of, like, you know, the point we're making. So, but as it is, you know, like, if you...
I think there is some amount of, like, you don't have to get a degree. It's just the other path is very low chance of success. Right? So the other path requires that you build something that matters and that people recognize as being valuable and impressive. Right? Like, if you wrote, I don't know what the educational background of the author of Curl is, right? But if you wrote and maintained Curl, it doesn't matter if you have a bachelor's degree. Like, people would happily hire you on the merits, right? Same thing with, like, I think, you know, if I didn't have my educational background, but I did my programming streams at the level that I do them, where I write, like, actual real software that's complicated, and I'd write it in front of a bunch of people looking at it. I think that's also something that can serve as, like, credentials that don't come from an institution, but that other programmers can recognize as being a sufficient credential. But it requires two things. It requires that you're able to produce that kind of not irrefutable evidence, but, like, solid evidence of your skills, your expertise, and not just in writing code, but in the social aspect of things, in your ability to take context into account, all of that stuff. But it also requires that the company you apply to is able to and willing to accept that kind of evidence. And I do think we're seeing more and more companies being open to that. Like where they're not just like, if you don't have a CV that says bachelor or master, we will not take your application. They're a little bit more open to unorthodox profiles. I think we're seeing a little bit of that trend, but you do see it more in smaller companies and startups than you would see at the big companies. Like if you try to apply to Meta, for example, I think, or Apple is probably another good example. I think it's pretty hard to get a foot in the door without having also the like the paperwork, right? Because they get so many applicants, they can just like pick and choose from.
The bright side there is the companies that tend to be a little bit more dynamic about these things also tend to be the companies that are better to work for, because like I would not want to work for like Facebook or Apple. That sounds like absolute hell, and like you only hear bad things about them. So like the companies that think a bit more about those things also tend to be the companies that actually like, you know, listen to their own employees about what actually makes someone a good programmer. Because I feel like, you know, a company that has bad hiring practices is often indicative of like, you know, the person who does the hiring has no idea about what makes someone a good programmer. So they're just like, well, I guess I'll just look for a master's degree. And so it's like indicative of like bad like internal policies and politics. So
yeah, I think that there's an interesting caveat to this too, though, because they're like some of the really big companies where the hiring pipeline is very standardized, and you will often be like hired by people who are far removed from the team you actually want to work for and all of that. They also have some really unique problems to work at. And so it's not as though the options are all equivalent. It's not as though, you know, if you choose to work for a small company, you get the nice things, which is you work for people that care more, that treat you as an individual employee and all of that, but you do lose something too. And so I actually think there's some amount of value in getting exposed to both of these or all of these, and then figuring out which one works better for you, and maybe get the experience from all of these and not just from a few of them.
Nico asks, what if you can get a degree? Is there really no way in? Well, of course there is. There's just like, you know, you just, if you can get a degree because it's like expensive or it's just like impossible for whatever reason, then you just gotta find a different path. You know, like there's always going to be things you can do, like networking, like just, you know, like just forming contacts with other developers, or like, you know, just producing something, making something that other people use, like anything that is going to put you on the radar of people who might then recommend you to their own companies, or just like generally help you out, you know. So if you can go the standard path, then there are non-standard paths, but it just means you have to like find that path.
Yep. There's also actually some amount of value in contributing to open source projects that are run by companies you care about. So if you find a company where you're like, they build really cool shit, and look, they've put some open source libraries out there, maybe I should go look at what I can do to contribute to those. Not to be nice to the company, like that's not really the primary goal, but it's twofold. It's one is exposure, right? You get to both be exposed to some of their developers and they get to be exposed to you. But it's also like preparing for potentially working there. Like if you get hired, you will now know a bunch of their code before you even joined.
Yeah, absolutely.
And so that can be one way to get some of that credibility with a company before applying.
Yeah.
And give you sort of leg up in the application process.
Aaron, you said you were talking about comp sci, but what about computer engineering? I don't know the term computer engineering. Do you, John? Does that mean something to you?
Yeah, I mean, computer engineering was sort of intended as a term that is more towards the vocational or trade side of computer science, because it's less science and more engineering, where engineering is usually seen as the more practical skill. Like if you study electrical engineering, you're like soldering wires. You're not really studying theory. And so computer engineering was intended to be more of that. I think in practice, they're almost used as synonyms now, sadly, in a way. But I agree that, at least technically speaking, the term computer engineering should be more like how we're describing programming here, of the more applied version of computer science.
It's not about the difficulty or availability. You study something else. Well, if you, like, just like, you know, this is a bit of a personal question, but like if you want to do... how come you're studying something other than what you want to do? It's not like, an accusation, but like I'm just curious how you ended up in this place, because usually, like, if you are studying something, it makes sense to like go into the field that you were actually, you want to end up in,
I mean, it's funny because to me, I am working with things that are very related to what I studied, but I think it's because in my mind, what I studied was not how to write a database.
Mm-hmm.
What I was studying was distributed systems, high levels of concurrency, high throughput, close to the metal kind of development. And that is what I do at my current job. Same thing with like a lot of what I was studying was like how to build Rust code. Like I started using Rust very shortly after the 1.0 release. And arguably a decent amount of my PhD was like figuring out how to use Rust for a fairly complicated networking project, which happened to align pretty well with both what I do now and what I did at Amazon. And that was also like being an early adopter of the language and knowing the build system really well came in handy there too. So I do actually feel like I use a lot of what I learned from my education in my work, even if the specific thing I technically studied is not what I do. So I don't think they're quite as unrelated as they might seem.
Pronoun says the reason companies go for degrees is that it just shows some sort of functional commitment. That's just, like I said, it's just really lazy though, making people go through 5 years of things that are at best marginally beneficial to them is like, just not useful to anyone, like that's just kind of wasted effort, like if it's not what they want to do, it's just not worth spending 5 years going in depth in subjects that you don't really need or want to.
The opportunity cost is pretty high.
Exactly, yeah.
I feel there have been surprisingly few concurrency questions. People have been bad at keeping send and sync in mind.
I think maybe I will step away for like a minute or two, and then if you're up for it, we can like talk specifically about left right a bit, if that works for you.
Let's do that.
I will be RB.
Now I'm alone with chat. We can do whatever we want. Oh, weird. My video crops over into the other side here. Why? OBS is very hard to configure correctly. Concurrency is easy to do wrong. No disagreement about that. Food fight. I like that. I just immediately pull up an editor and just start a live coding stream. Although I feel like realistically, I would need to program either like with the laptop like here, because I can't screen share into the stream, right? So I either need to do that or like a whiteboard or something, or I would just need to program in chat. What are my earphones? Oh, I recently got these. They're Shocks, so they're like the bone conducting ones. I got them specifically because I don't need them to have a good microphone, and so because I have an actual microphone. And partially because I wanted them to be open ear. So I wear these a lot for work meetings and everything. And I'm in like a sound isolated office. So there's no need for me to have big headphones. I'd rather something that's very comfortable with glasses and everything. And these happen to be open air and very light. And so I was like, sure, I'll try these. I used to have some really good headphones that were very soft and nice and open ear backed. But they were wired, and that was really annoying when I wanted to I like to move around on my chair a lot, and when you have a wire, that's complicated. So Bluetooth it was. I've only had them for like a couple of weeks, but so far I'm pretty happy with them. They're technically the Open Fit 2, I think they're called. Did you do your PhD in concurrency, essentially? Well, so technically my PhD was in writing incremental view maintenance systems for databases. It's just that in order to implement an incremental view maintenance system for a database efficiently, you need to do a lot of concurrency. That's like how you get efficient incremental view maintenance and efficient caching. So that was a lot of the stuff that I did during my PhD, even though it wasn't technically the goal. After Golang, it seems Rust is kind of useless in the question of concurrency. Why do we use concurrency in Rust less than in Go projects? Like, people are afraid of it. I don't think there's less concurrency in Rust. Quite to the contrary. I think people, like, if you look at all of the programs that use async, they're effectively concurrent programs, right? They are concurrent programs. It's just that you write tasks instead of threads, which is exactly how it works in Go too. When you start a Go routine, you're not actually starting a thread. You're starting a task on the Go runtime. And I think we see a decent amount of actual threading in Rust too, and this is where send and sync end up being really relevant. And I do think that is a meaningful step up from Rust. Like, Go won't really protect you from making mistakes in how you spawn Go routines, for example, and how you synchronize between them, whereas Rust will. Have you ever made good use of static scheduling? I never came across a problem that was confined enough. No, static scheduling is like, it's pretty niche. And you kind of, like, I feel like the place it ends up being useful is if you need to write highly real-time systems. And highly real-time systems are a pain in every way. And so it tends to be a problem domain I try to avoid. Can you recommend some good concurrency projects to get good at it? It depends on what you mean to get good at it, right? So there's sort of two sides of concurrency. There's implementing concurrent algorithms, and then there's writing programs that have concurrency in them. So programs where you have to write to have concurrency in them is like almost any program these days in Rust. Like anything that uses Tokyo is inherently multi-threaded. Anything that builds on top of something like Rayon is inherently multi-threaded. But if you want to implement your own concurrent data structures, then you're in a whole different kind of world. What I would actually expect if you really want to learn how concurrency works, try to implement some lock-free data structures yourself. It will be a pain, especially in the beginning, but it's really fun and you learn a lot from it. Like this could be even things like look at, there are something called Triber stacks and what's the Q version? There's a Q too, but now I forget the name of it. But there's basically two fairly basic concurrent lock-free data structures for stacks and queues. Try to implement them. It'll be a fun journey in concurrency, especially trying to write tests for them as well. And afterwards, you will understand concurrency a lot better.
That was your response to the button to fire missiles, right?
No, this was the can you recommend some good concurrency projects to get good at?
Right. Do you want to show off left, right a bit on your screen? Should I open it on my screen?
You can do it on your screen. Okay. That's fine.
Here, let me do this thing here. I have the chat over me. I'm fine with that. I don't know how to fix that right now. Here, okay. So
I feel like there's probably space like in between the right-hand side of the page and where our faces are. But it would require like actually doing it online.
No, I just moved it.
Nice. There, that perfect. I see no problems. This looks perfect.
Okay.
Right. Cool. Okay.
Left, right. This is so to give a bit of context. Actually, you know what? You talk about it a bit. I'm gonna finish my piece of candy so I don't sound so dumb and.
Sure. Okay. So left, right is a relatively low-level concurrency primitive. It is not a data structure you would use directly. It is a data structure you would use in order to implement a concurrent data structure yourself. And what it gives you at sort of a, like if we try to take a long step back, is it gives you a way to have a data structure that's updated by a single writer and read by many readers at the same time in such a way that the writer never has to, the readers never have to wait for the writer to finish an operation, and the readers never have to wait for each other in order to access the given underlying data structure. You can think of this a little bit like a reader-writer lock. So in a reader-writer lock, like an RW lock from the Rust Standard Library, you can either have one writer or you can have many readers. And so many readers are allowed to coexist. But this has the property that if you have a writer currently holding the lock, you get to have no readers. And if you have any readers, you can't do any writes. Left-right is not like this. Left-right allows you to have a single writer and many readers at the same time. However, the trade-off that it makes is that the readers see a stale version of the data that's being stored. So they do not see the same copy of the data that the writer is mutating. The writer modifies their version of the data structure, and the readers read from a different copy of that data structure. So the other trade-off here being that you actually have two copies of your data structure at the same time. The one that's being accessed by the writer and the one that's being accessed by the readers. There's then one atomic pointer that switches back and forth between them. So the writer chooses when it exposes all of the changes it's made to the readers. Then the readers sort of slowly but surely read the updated pointer, file over to the other side. And when all of them are made over to the other side, the writer takes over the old reader map, brings it up to speed so the two copies are now equal, and then allows you to continue to do writes. So in other words, the writer can block, but the readers never block. And this is really useful if you're writing some kind of data structure where you expect to have a lot of readers that need to do really fast operations, and you expect writes to be relatively slow and handled by, one thread effectively. So this is eventual consistency, as someone rightly pointed out in chat, that readers will eventually see all the edits made by the writer, but they will not see it necessarily straight away. They see it when the writer chooses to expose that information. And then this is sort of the high level of the data structure, and then we can talk a little bit about how it works at the lower level, but we should first understand the higher level concepts. So let's do maybe questions on that first. Of what does it look like? What does it feel like?
And to give a bit of context, I first encountered EVMap and left-right 5 years ago when I was doing a chat server, much like I'm doing now for a company, and that project ended up falling through. But so I was already dealing a lot with eventual consistency because we had multiple distributed servers that communicated with each other, that committed all of the events they were generating to a central event buzz in Kafka, and basically they eventually got the consistency of those events through Kafka. And as I was using RW log for my states and using eventual consistency, I remember I think a colleague brought up, hey, I found this thing that's a data structure made for eventual consistency. You should check this out. And it is so because there's so much state consisting of primitives that each server node has to deal with. It's a really good fit when you want to prioritize performance, but it's memory use is not a big deal because it's a bunch of integers and stuff like that, so it's no issues if they exist twice in memory. And since you asked, do you clone one side to the other when swapping or try to apply the changes? You apply the changes twice, so the way it works, which was a really good fit for the way I'm doing things with the chat server, is that you have usually an enum, a list of events that gets applied to both sides of the left-right data structure. So first it does the one that's currently not being written to, and then after swapping them it applies them to the other side too. And ideally, you don't have to clone the entire data structure every time you swap, but you just keep track of which changes you have applied to the other side previously, and then you bring the second copy back up to date. And that worked really well because
you effectively keep a delta, but you keep the delta in the sense of an operational log, where you only keep the part of the operational log that you have not yet applied to both sides. The moment you've applied it to both sides, then you trim the log. You only keep the sort of tail of the log over time.
And it works really.
And it's actually slightly better than that in that this depends on the exact way in which you're using left-right. But left-right does give you the ability to alias between the two copies as well. So rather than keeping duplicates of all the data, you keep duplicates of, for example, the hash map, but you actually have a way to deduplicate the values in the hash map. So that you only keep the values once, but you keep two pointers to them. So there are some of those optimizations you can apply as well, but they obviously require some unsafe wiring in the person who writes the data structure using left-right. And we can look at that in a second, like how exactly that gets exposed to application authors.
I think it's worth pointing out here, and that's like, you can correct me here if this is a misunderstanding of mine, but the aliasing is really like specific to Rust. It's like, kind of working around the borrow checker. Like if this was like, C or something, you would just use a pointer. It's not something you would have to consider. It's like a way of like as safely as possible working around the safeties of the borrow checker, basically, because normally you wouldn't be able to have like two supposedly owned values that represent the same bit of memory.
Yeah, and to be clear, even in left-right, you can't make them both be owned because they're not owned, right? Like if they were owned, then Rust would end up in a really bad position when deciding to drop one of them, because now you're violating the sort of drop requirements and the uniqueness requirements. And so there's like a bunch of trickiness you have to do here. And if you had a garbage collected language, this problem would just go away, right? You would just keep two pointers, and when both the pointers are dropped, then it gets garbage collected. So there's no problem. Whereas in Rust, you actually do need to keep track of, is this pointer in both sides? Is it only in one side? Is it about to be added to the second, or is it about to be removed from the second? And so on.
Baum asks, why did he use an atomic pointer rather than just a structure with both sides in it and a smaller atomic that decides which one to use?
So those effectively end up being the same, right? So it's either you keep a struct that has two fields and it has an atomic bool that decides which field you access, or you have just two allocations that hold the data structure, and you have an atomic pointer that chooses which one to go to. I think in reality, you would end up having to use pointers here regardless, because if you had a struct that held two t's, right? Left, right is generic over the data structure, so it's generic over some t. Then you would keep field, like left is a t and right is a t, but that's not really true, because that would imply that you have an owned T on both sides. And ownership implies that you have exclusive access, which you do not, because there are readers and writers, so it's being shared. And so realistically, you have to indirect it through a pointer, because you can't store it as an owned value, because you would be lying to the Rust type system by claiming that it was owned.
Do you hijack some reader's thread to do this? No. So the way it works is basically you just as you write changes to the map, you don't actually write them directly. You just like append them to the log, and only when you publish do you. But basically, you wait for the readers to settle on the like you bring the copy that's about to become like the read copy up to date. Then you swap them, and once all of the readers are now looking at the new copy, you are still on the writer thread, applying the changes to what was once like the copy you just acquired. And I'm sure John can explain that a lot better.
Maybe it's easier to show this if you pull up the absorb trait.
Of course. You mean the documentation or the code?
The documentation for the absorb trait.
Absorb.
It should just be near the bottom.
Yeah.
So the absorb trait is what you need to implement for the data structure you want to build on top of left-right. And if you go to the top of it, just so you can see the list of methods, when you implement absorb, the thing you have there is you have to implement absorb of each O, where O is the operations that go in the operational log. Right, so the operational log are every time you do a write, it has to be possible to turn it into one of these O's. Like every write operation is an O that gets added to a log. And the absorb trait explains how do you take, when you have a T that is owned, or that you have exclusive access to because you're the writer and all the readers have left, then given a list of O's, how does that change your data structure T? That's what the absorb trait tells you. And so this is where you get to express how the op log turns into changes to, for example, a hash map, right? So if you had a left-right where both sides were a hash map, the O's would be an enum of insert and remove. And those are the only two writes you really do to a hash map, right? So the O's would be an enum of those two operations. Absorb would be apply that insert or apply that remove to the map, like to the mutable reference to self here, which would be a mutable reference to the T. And that's how you update the data structure. And you'll see here that there's absorb first and absorb second. Absorb first is when the O is applied to the first of the two maps, and absorb second is when it's applied to the second of the two maps. And the reason these are separate is so that you can implement this aliasing, right? So you can implement that when you absorb it the first time, you just take an alias to the thing that's in the log. Because as you see in the operation that you get access to in absorb first, you get an exclusive reference to the O, but you don't get ownership of the O, because ownership has to be passed in absorb second when it's applied for the second time. But you do get to do like aliasing here if you want. And similarly, there's drop first and drop second, which is called when the T is dropped in the left and the T is dropped in the right.
And so it's like, to sum up, it's like basically all of these, everything that's not absorb first is basically just to do optimizations. Like absorb first is the one that that like you can get away with only implementing these two. Like just absorb first is like, you know, applying the operations. I think sync with only gets called once after the first swap, I believe. And
so sync with is like an optimization where you've done a bunch of initialization of your data structure and written everything to the first of the maps, or to left, let's say. Now, the first time you do a swap, it would be annoying if you had to apply the entire oplog for the whole initialization. And so there's an optimization where you get to just like initialize right to be a copy of left.
And then like absorb second, like, you know, you only need to implement if you're like, you know, if you actually want to do something different, like with the owned values, or you're like, you want to do the aliasing, like, you know, for instance, in absorb second, you could like, if you have to clone and absorb first, and you wouldn't need to do that in absorb second, and drop first, drop second.
You can see here that the absorb second, drop first, and drop second are all provided methods. They are implemented for you by default, and they do something sensible. So you only need to implement absorb first and sync with. And then I think the other thing that's useful to talk about here is how does left-right actually realize that all the readers have moved from one map to the other? Because this is the other part that's not entirely obvious.
I will pull up actually the code for this so you can look at that. Here, repository.
I think I would just look at. Yeah, exactly.
It is in the writer. It is, where is it?
In right,
it is in publish, I believe.
Yeah, it's
here. It's in weight in particular, I believe.
Yeah.
Here.
Specifically, weight is the tricky one. So the setup here is that every reader has an atomic U size that is sort of its generational counter. Every time a reader is about to read the atomic pointer, it increments its generation. Then it reads the atomic pointer, and then after it's finished doing its operation, doing its read, it increments the atomic pointer again. So the atomic pointer is always even if the reader is not currently doing an operation, like it doesn't currently have a reference of any kind, and it's odd if it's in the middle of doing an operation. The trick now is, as a writer, the way you confirm that there are no readers, like you swap the map pointer, right? So all the readers are currently in this map. And you want to wait until all the readers are in this map instead. So you swap the pointer to point to the other map, and now new readers start going that way, but the old readers are still here. And then after swapping the pointer, you read all the readers' generational counters. When you've read all of them, you now go into a loop where you read all of them until you've observed all of them either being even or having been incremented. If they're even, then you know that that reader has not yet read the atomic pointer, and therefore you know that if they choose to do it, they must read the updated one because you've already changed it. If they're odd, then you know that they may have read the old value of the atomic pointer, so you need to wait for it to either become even or become a higher number. If it becomes a higher number, it means that they've finished an operation and started another one, which must mean that they've read the atomic pointer again, which must mean that they've read the new value rather than the old value, which means they must be in the other map. And so in the wait loop here, you'll see that it has this last epochs array that keeps track of what was the last epoch you read for all the readers. And then it just walks through all of the readers, and for each one checks whether the epoch counter has been increased, and if so, it moves on to the next reader. And at the end, when it's looped through all of them and found that all of them have changed, or all of them are even, then it goes, okay, I now know that there are no readers in the old map. Now let me return from wait and give you an exclusive pointer to this map, because I know that no one else has access to it, so you're allowed to write to it now.
5G asks, can you prevent desync through internal mutability? So it's really important that you don't have internal mutability in your two copies of state, because otherwise you're going to, like, I don't think there's a way to prevent that, because like interior mutability is like, if you have something that is not in itself not mutable, but it like allows you to mutate its inner state, then if you only do that on one end but not the other, then you have a desync. But I don't think there's a way to prevent that.
So this should be this should sort of be enforced a little bit by the API, right? In the sense that if you have the two sides, and actually, I guess if you had, for example, a mutex be the value that you have on both sides, then in theory, getting a read handle to the mutex on one side, you could modify that one side. At the same time, usually you would then have a mutex that's pointed to by both sides, so it's the same mutex. And so you probably actually do keep them in sync, but it would get really weird because when you apply the operational log to the other side, you've already updated the mutex state, and so now you get updated again.
Yeah, exactly.
It would probably be weird.
Yeah, so...
so you almost certainly don't want to have interior mutability on the two sides.
Yeah, like if you use like a, like say, dash map is the first thing that comes to mind that exposes like, non-mutable methods, but it has interior mutability, so if you use something like that and you only like, you have a read handle and it has like a dash map and you edit that only on one side, then you're gonna have a desync, because like you cannot really, like, if you use left right, then you basically need to make sure that you don't only through the read handle or something, like, edit something, but not the other side too.
Yep. Or you need to ensure that you, the op log only ever adds items or removes items. It never changes them.
Yeah.
And then you need to guarantee that the two sides are pointed to the same interior mutability structure.
Yeah.
That would be the other way. But this is what I mean by left-right is sort of intended to be a low-level concurrency primitive, not a data structure in and of itself. Like, I don't generally expect that like application authors deal with left-right. I'm expecting someone to write their own data structure that internally uses a left-right, and they have to understand all this nuance and how to use it correctly. But hopefully they're able to hide that complexity from their users.
It says somewhere that you need to make sure that the two like absorbs do the same thing, or there could be subtle desyncs. I don't know where
I think
it says
that's on the absorb trait almost certainly. There's also the deterministic application requirement that's near the top of the docs.
Here, it says, note that this method should modify the underlying data in exactly the same way as O modified other, otherwise the two copies will drift apart. Be particularly mindful of non-deterministic implementations of traits that are often assumed to be deterministic, and of hidden states that subtly affect results. So, basically it's like left-right is, although it is safe Rust code, so it doesn't have like actually undefined behavior, you do need to be mindful when using it.
Yeah, it doesn't prevent you from writing business logic that means the two sides are not the same, which means reads see different things. But it does prevent you from just like violating memory safety. You could, for example, nest left-right inside itself to have some part of your state update faster than the general main state. Let's see. If you nest a left-right, it's not clear that works, because the way left-right is set up is that you can have as many readers as you want, but you can only have one writer. And so it's not entirely clear what you would nest. If you nest the readers, then the two sides are going to be the same, because both sides just hold a reader. But at that point, like, it's a little unclear why you need to keep in the left right in the first place, but you could. I think that would be fine. But the writer would still be stored somewhere else. If you try to stick the writer in a left right, then you wouldn't be able to use the writer because the writer requires you have exclusive access to it in order to make any modifications to the data structure. And left right never gives readers access to the exclusive. It never gives you exclusive reference to the data. So then you would need a mutex of a left right writer. So nesting them is actually fairly hard here, I think.
So I wanted to ask you about something, and this is actually something where the documentation is wrong, so we might actually change this. So what it says here, and this is not what the code actually does, it says, when a write occurs, the writer updates the other T for which there are no readers, and also stores a copy of the change in the log. But what actually happens is it only appends to the log, and then makes the changes to both of them when you call publish. And so I wanted to know why it was done like that, and basically align the documentation with what the code does. So when we look at, yeah, so...
Is that true? I know that some of this changed at one point, because I realized that you could be more efficient by delaying the wait until the next publish.
So when you look at the append only doesn't extend. And extend, if we're not first, it only does like an oplog extend. So it does not immediately apply the change to the copy the right handle
does the
currently
documentation of append say that?
The documentation of left right itself says that, like on the top level. Here. This here.
Yeah, okay. Yeah, this changed. Because it used to be the case that left right would ensure that the writer always had exclusive, like whenever you had exclusive access to the writer, you knew that you had a map that was empty of readers. And so therefore, append would immediately apply the operation the first time, and then not necessarily immediately apply it the second time. What I realized was, that's actually kind of dumb, because it means that you don't get to have concurrency between the writer and readers that are leaving the map. So the way it's been changed is that now, when you call publish, publish will guarantee that readers see the updated values. But it will wait for the previous swap to have taken effect. And then it will apply the changes the first time to that one. And then it will start the wait, but not finish the wait for the next swap. It's actually not quite true that it applies it to both of them at the same time. Because what it does is sort of a phased application where what publish will do is it will apply the prefix of the log it will apply the whole log. Let me debug my brain for a second. It will wait for the previous swap. So the swap from the previous publish to fully have completed. Then it will apply the entire oplog to the map that is now reader free. It will not, however, apply any part of the oplog to the other side because the other side has readers now. So it ends up basically applying the prefix of the log, like the oldest parts of the log that haven't been applied yet, and then truncating it, and then applying the rest to, so it applies second to the part that it truncates, and it applies first to the remainder. But then it leaves that remainder for the next publish cycle. So I think the way I would fix this in the docs is just to change it to say that that also happens on publish, or I would just remove that sentence.
Yeah, because it does do, like, when white handle publishes call, the writer atomically swaps the reader pointer to pointer the other T. That's true. It then waits for the epochs of all current readers to change, and then replays the operational log to bring the stale copy up to date. So it does do
that part is, those parts are all true.
So it does do the, it does the, so the wait is, what does it do,
but
the
it's
swap?
the weight of the previous swap is the trick. This was like the change that was made.
Yeah.
So the weight that happens here is a weight on the pointer swap that happened at the end of the last publish.
Right. So basically
Rather
it uses the time between publishes to do its swap rather than waiting for it at the very beginning up front. That makes sense. So it's basically it is a optimization only for the writer, to make the writer have to wait less when it publishes more often, basically.
Exactly. And so I think the way I would update the documentation here is something like, when a write occurs, the write is added to the operational log. Full stop.
Yeah.
When write handle publish is called, the writer waits for the epoch of all current readers to change, and then replays the operational log to bring the stale copy up to date.
And then
it then atomically swaps the pointer such that readers get access to the now updated map. Or now updated side.
Yeah.
Fun times.
Yeah.
But yes, I agree. It's as currently written, it's wrong. It's based on the way that this used to work.
Yeah.
Which is, it used to be the case that doing an append would immediately apply first.
Yeah, and I was wondering, like, I figured that this was something that changed, but I was wondering why you changed it. But it actually makes perfect sense because, like,
it ends up with, like, the writer being able to move much quicker because you basically get sort of IO concurrency effectively.
Yeah.
Like, you get concurrency with your readers or with your wait.
And that's also why we need, like, the last epochs here. So we swap here and then we assign the last epoch. So, like, here it's actually pretty likely, like, if the last write was like a little while ago, it's very likely that they'll have all changed.
That's the idea. So it actually means that publish rarely has to wait at all.
Yeah.
And so you do the swap, you do the wait, then apply the oplog, then do the swap, then read the epochs, and then return.
Yeah. I can see how happy you are with this. I love it.
Yeah. And when I realized I could do this, I was like, yeah.
Yeah. Yeah, exactly. So we so basically you wait while you wait while doing nothing, basically. So you
wait while the writer is executing other code.
Or nothing really, like, because the writer might just you wait while you're not publishing, basically. So the publish is the only path that requires taking a log in big quotes, because it's not actually a log, but it's like, blocking, so it's the only part where you end up wasting time. And so
the idea is basically you yield the wait time back to the caller.
So you started here because
I don't think it actually optimizes. So there's a comment in chat here that it optimizes for writers to call write often but publish less often. I don't think this actually hurts anyone.
Yeah,
I don't think this ever slows anything down, because it strictly lets you overlap the wait time with executing other writer code.
Yeah. I mean, the only thing maybe is that, like, you could maybe, like, optimize this thing away a little bit, like the last epochs thing or something. But it's like,
So I think you need to, if you don't read them right before returning, then you don't get the overlap, because you need to give the readers time to increment their epoch counters. And the only way you do that is by having read an older value.
Yeah, that's true.
Which means you can't read it later. And so it reads it as quickly as possible after the pointer swap.
No, I mean, like, if we weren't, I mean, like, that might be the only, like, extra cost we incur from doing it, like, in this order. But, like, even then, it's like, it's just super worth it to do, like,
But you would need to, even if you didn't do it this way, if you did the wait at the start of publish, you would still need to read the epochs you would still need to do the pointer swap, then read the epochs, and then read them again. Right? So you still have to read all of them once.
Yeah. True, yeah.
Yeah, the config test blocks also make me happy, but that's sort of a separate observation. This is like some extra stuff that's handy in debug mode.
The other thing that happened, and I might just like open PRs for this, like, you know, the other thing that happened is that like flush doesn't actually work if you're like, you know, if you've never called publish, because has pending operations will never be greater than, because like it'll write the operations directly. So I might just open PRs for like the little things that came up. So,
Yeah,
like,
that's
the
a
dog
good
thing
idea.
and yeah. But it's like it's working super, like it's working super well for me. Like it's just a really
Nice.
cool. So I'm curious how you feel about my idea of, and let's chat about that a bit, like my idea of, so what I'm doing here, and this, I'll just pull up my code a bit and I'm using it here. So where do I actually create it? So the way I do it is
wait, there's a question in chat. The design means that the writer actually can never read. With the obvious design, the writer can read the current state and it will fit with the applied ops. Yeah, if the writer reads, they will not read their own writes.
Yeah,
They can read,
like,
but
yeah.
they see the same state as what all other readers see.
Yeah. That's like the only like downside is that like if you would want like a like reader reference to the right handle that's always up to date, then you can't like up to date with your latest writes, then you can't have that. I did actually have to work around that too in my code, that like you cannot have like the writer like use it itself as like state basically.
Yeah, there is an interesting way to do this, right? Which is you basically just call publish. That's the solution. Like when you call publish, then you get to read your own writes.
Yeah, that's actually what I ended up doing. It's like, so basically I have like the I have so basically the events come in from nats, and I call so I append them to the writer first, then I publish, and then I do like the code that's based on the state having changed. So like we want to do your state changes separately basically.
Yeah. The thing that's really funny here is also that, like, I think by far the most common use of this crate is to do one append and then one publish immediately after. Right? It's very rare that your oplog has more than one thing in it. But it is possible. Yeah. Right? But I don't think very many make use of it, because realistically, you very often want to immediately expose the changes you made.
I mean, but it's great to have this option, because like here I'm doing an append and then I'm doing a publish, but I could just as easily pass in a batch of events here and just like have a little more eventual consistency. So while I'm doing this right now, I did very much build this around the idea that there could be like batches of events coming in here that I'm like, you know, first appending, then publishing all at once, and then sending out the notifications for it.
The way I've seen this done in the past, for example, is when you have a stream like this, you try receive from the stream until the stream would block. You treat all of those events as a batch. Yeah. And then you call publish, and then you block or wait. Yeah. Because that way you get like anything you get as a burst, you treat as a batch. Yeah. Is there a variation where the writer never blocks, but just writes to the oplog until it has exclusive access? Yeah, I think there's a try publish or something. I forget whether I ever added this.
I think so. Let's see. If we look at left, right, right handle.
Yeah, it would be on right handle.
I think it might be an issue or something. I did see something like this. I don't remember where though.
Yeah, but because this should be easy to add, right? To add a mechanism that is like check whether it's now safe to apply the oplog, and if not, then don't. And it would basically be a try publish that returns a bool or something. Yeah. Should be pretty easy to add.
Because you really just need to. I mean, you basically just do. you just do you just do this check once, right? You basically have to like not use weight.
It's basically the weight. Yeah, it's weight, except it only loops once.
Yeah, exactly.
And it's the first half of weight, I think. Or maybe it just is all of weight, but only loop once. And it returns a Boolean about whether it broke early.
What's the story of the Loom thing, by the way?
Well, so Loom is a concurrency testing crate.
Okay.
That was written by Carl Lurch, the same guy who wrote Tokyo. It's a really, really handy mechanism for testing concurrent code.
Oh, okay.
So it basically runs all possible interleavings of concurrent data accesses. Like it basically, instead of using like an atomic bool or atomic pointer from the standard library, you use them from Loom instead. And then Loom will, same thing with thread spawn. And Loom will run every possible valid, like according to the memory characteristics of the language, every possible interleaving of reads and writes and what can a load see and what would a store see. And so by running this through Loom, you basically get like semi-exhaustive testing of all possible thread interleavings.
So this is purely for testing, basically.
It is purely for testing.
Okay. Out of curiosity, why is it config Loom and not config test then?
Because you don't want to run it in normal tests. So Loom Loom requires, so you basically have a Loom runtime around your entire test.
Oh, okay.
And so if you're not running a Loom test, then you don't want to use the Loom types because they wouldn't work.
I feel like I remember seeing the does this EV map have try publish or something? I feel like I remember seeing that somewhere. That sounds so familiar.
Could be.
Clear empty fresh.
No, I don't think so. But I agree with you. I feel like
it sounds so familiar. I feel like I've seen this.
Is it in the alpha actually?
Maybe. There's also only a wait. Where's the publish? Right, it was renamed to publish, but there's also no try publish. This is crazy. This is like Mandela syndrome right now, or Mandela effect, where we know there's a.
It might be that there's an open PR on left right.
Maybe it's a PR.
Or on EV map.
This is crazy. Where have we seen this? Where have we done this?
Yeah, I'm not sure. I'm not sure. But maybe it's actually just a comment in the code that we could add this if we wanted to.
Yeah,
I'm
maybe.
Sure. But I mean, hey, if someone's feeling up for it, add it.
Yeah.
Seems like a fine thing to add. Would the oldest held state plus an oplog that gets merged into the state on the drop of the oldest reference be too bad for performance? So the question is where that code runs. That's the problem, right? So if you want some code to run when the readers have all left, then either it's a separate thread that just waits for that to happen, then does something. And then the question becomes, who runs that thread? Ah, yes.
I remember reading this comment and you remember writing it.
Yep, perfect. Nice, okay.
Sorry, I didn't mean to interrupt.
No, you're fine. You're fine. It's good that we found it.
Yeah.
So you either need a separate thread to be the one waiting for that condition to happen, or it needs to be the thread that owns the writer. But if it's the thread that owns the writer, then you're blocking that thread, which is the same as just making publish be blocking in the first place.
You were replying to 5G's question, right?
5G, yeah.
Sorry, how do you get from there to needing the writer to be? Sorry, I think I.
So the question is like, can you have a way where you keep the oldest held state and the oplog that's merged on the drop of the oldest reference?
On the drop.
Like when the last reader leaves and something happens. There's a variant of, like, there's another interpretation of this question, which is, could you make it so that it's the reader's job to do this work?
Yeah.
But I don't think, I don't think you easily could, but I also don't think you want to, because it means that the readers now have like an expensive path. Like sometimes readers are slow because they need to do the swap work on behalf of the writer. And part of the whole point of the design of left-right and EV map was to make sure that readers never block. They are never slow.
And it's also just like kind of complicated because like, you know, what if you you then start running into a lot of like concurrency issues. Like, okay, so like what if one reader is just taking like a while to do it, and like, you know, the writer wants to publish twice in the meantime, and then it's like, you know, you just introduce so many like synchronization issues between the two, basically, because like right now readers don't need to know about the uplog at all. So there's
it is worth pointing out though that in left-right, readers can starve writers. So if you have a reader that holds a handle into one of the sides and just keeps holding onto it because it's doing a really low, slow, expensive operation, the writer will not be able to progress past the publish. Like that is if they do 2 publishes in a row. They'll be able to do the first publish, but not the second, because then they need to wait for the pointer swap of the first.
So it's like really important to hold your read guards as briefly as possible, because like, you know, ideally you just like basically treat it like despite it not being a log, you should like ideally treat it like as if it was like a mutex guard or something, because like it
and the other way to even think about this, right, is that if you have this kind of behavior where the reader can actually block for a long period of time, you should use a lock. Right, like that's what locks are great at, is if you have like multiple axes where some of them will block for longer periods of time. And EV map is like specifically not designed for that kind of use case.
And that's actually like a good lead into like, you know, what, and you just mentioned one, but like generally, when would you not use left, right, or EV map?
I think there's a documentation paragraph on this at the top of the left-right docs, which is like, what are the trade-offs you're using by using or making by using this library? So it says like, here are the trade-offs. Like this, the increased memory use, right? You have to be willing to keep 2 copies of your data. You have to be able to express the operations on your data as a deterministic log of operations. And that's not always trivial. And sometimes even just keeping that log can be really expensive, right? Because now you need to keep like owned copies of your keys. You need to keep owned copies of like data you need to write. There's a bunch of potential costs with having to keep this op log. It also requires that you only have one writer. So if you have multiple writers, you basically need to put the write handle in a mutex. It gives you no ability to do things like have concurrency between writers. This is where you would want to use something like dash map, for example, if you or papaya, if you wanted like a hash map specifically, like that's the interface you want with concurrent writes and reads, where the writes can be concurrent with each other. Then you need something that has like fine-grained locking, which EV map and left-right don't have. And the last is like writes are slower in this setup, because you have to go through this double swapping, because you have to wait for all the readers, because you have to go via this operational log that needs to be applied. Like writes are just a much more costly operation, both in terms of cycles and in terms of wait time. And so if your writes are on the critical path in some meaningful sense, left-right is not the data structure for you.
Yeah, so what I've done here, and what I really want to get your take on, is that, like, you know, as I was, like, still, I was, like, just about to start to, like, you know, writing my own data structures based on left-right. I was, like, going to make, like, a like, you know, single value map. I was going to make, like, a multi-value map, and then I was like, wait, so my entire data structure consists of primitives. Why not just make the entire state the left-right? So I have, like, the thing that just, like, constructs my state, which is, where do I construct the states? Here. I have just like a simple state, which is just like a few hash maps. And this entire thing is because, like, you know, I process events from Nats or Kafka or whatever. So I literally just have the state implemented as an absorb of the events from Nats onto the state. And so, like, for every event that I get, I just apply some kind of operation to the state, and then afterwards, like, you know, I have an updated state, and I can, like, send out events, notifications, whatever. But so I want to get your take on like what you feel about like making the entire state the thing that's managed by left right.
I don't think it's unreasonable, actually. I think the main two arguments I could see against it are if you ever expect that you will update this subsets of this data structure from different sources. So currently it looks like all of the updates come from one stream.
Yeah.
But if you imagine that like some subset of the state is actually updated from some other origin, like there's a second event stream, or there's like RPC requests or something that come in, and those want to update just the groups field or some such, then now you run into the single writer problem of that's pretty annoying. The other one is if you start having an application setup where it's not like unidirectional, in the sense that it's not just that there's an event stream that comes in and updates the entire state, but it's also that operations might flow the other way, that like some of your other things that operate on the state also want to mutate the state, right? Like they want to persist something for longer term storage or for other readers to see and that kind of such. Like that kind of like access pattern is just like doesn't work with when you try to use left right here. But as long as neither of those are things you expect to happen in your application, then I think you're fine.
Yeah, I mean,
this
like,
seems like a great way to get reads to be really fast.
Obviously, this isn't like, the entirety of the app state. Obviously, there's like, things that like, there are bits of memory that are not managed in here. But like, the way I think about it is that like this state is just like a in-memory cache of like the state of the system, so like there's there's NAS or Kafka to like process events and like distribute them to the different nodes, and there's persistence, which right now is just SQLite but will eventually be whatever that's like per node, so like every node like processes those events, stores them to its own local storage, and then like propagates them into this cache basically. So it does that here. It stores them into like it sends them out using a Loom channel to the to left right, and then just stores it into the database, and only after storing
that seems totally reasonable to me.
And it's just super convenient because it's like incredibly fast, like there's like I have like all of this without any locking, and so the way I've done it is that I have like different like API endpoints that I process basically where I generate these events. And the way I do it is I have the actual function isn't async, so it just loads the things it needs from the state. So it only has access to the state in a sync manner, and then moves what it needs from the state into a future where it can then generate whatever event it needs to do.
Where do you clone the readers?
The readers are per request. So the read handles are, because this is Actix, it has like a read handle per thread, and then
I see.
A read handle per thread and a read guard per request. But the read guard only lives synchronously.
Okay, but there's a reader per thread and a read guard per request.
Yeah, exactly.
I see. Yeah, that seems fine. If you started having one reader per request, then creating new readers can also be slow.
Of course, yeah.
But if you, as long as you just have one reader per thread, you're in great space.
Yeah. So it does this. Where is it? Where do I do here? So it creates the read guard here. Does like the auth it needs, and then it executes the like endpoint synchronously, and only then is it actually awaited.
Yeah.
And this is like because I'm using like protobuf, this is like just a little bit of generated code I have like with it's like
you could even where are you storing the reader at the moment? Like how do you get it to be per thread?
This is just Actix. So like Actix basically has like this this factory. It runs like this closure gets executed per thread. So it just spins up worker threads, and this just executes this closure per thread. And so it just clones the reader per thread.
And it guarantees that it does it per thread because Actus gives you
Exactly.
per thread execution. Yeah, because the other way to do it would be to actually use a thread local, and that would have worked too.
Yeah, thread local is probably a
Because
really
that's
good way to really good thing to use for left right. I would assume.
Yeah, because the neat thing with left right's read handles is that they are self-owned. So the read handles also carry basically an arc to the data structure, and so they don't depend on having a reference to like the shared reader or anything. They they're internally reference counted rather than externally. The only thing that would be annoying about keeping them in a thread local is that they would never be dropped. Because thread locals, I believe, are never actually dropped.
I'm assuming when the thread is gets destroyed, then when the thread gets dropped, and the thread local would also get dropped. No.
I think it depends actually. Like if the main thread exits, then all the threads are just torn down and they don't actually drop. But at that point, your program
it doesn't matter. Yeah.
So it doesn't matter. Yeah. So usually it doesn't matter.
Yeah. No. Like it's only when you. I mean, if you have something that needs to be like actually cleaned up, you probably don't want that to be in the drop anyway, because then you start running into like I had like some library recently that I don't know which one that was. It was some I think it's like the Nats library or something that like does something async in the drop. Like it creates like
yeah, this is like what I was talking about earlier, right? That one of arguably the design problems in Rust is that we added async after drop was stabilized, because drop was stabilized in 1.0, and it means you don't have a way to do asynchronous drop, and you don't have a way to pin and drop, and it's a real pain. And then libraries have to work around it by like getting a handle to the current executor in drop and then executing an async thing there, and it sucks.
And then it crashes, because like it's the runtime's already being torn down, so it's like, no, what do you mean? No, I can't start another task now. And so it just panics. It's like I think it's the Nats consumer or something that does this.
Yeah, there's been some like design work on figuring out like how can we actually add async drop to the language, but it's just really hard.
Yeah, it is. Yeah,
it's like not obvious how to do it at all.
I can't find it now, but it's like it was some library, and I was like panicking suddenly. I was like, wait, what? Like while restarting, and I was like, wait, what's happening? And so
this is not uncommon. Like specifically the panic when a thing is dropped during runtime shutdown. Very common, like until someone runs into it, then it's a pain.
So yeah, I do think that probably because like the question was asked before, I do think that eventually we are going to see an even better successor to Rust that's just going to, because that's what makes Rust so good, is because it was built from the ground up with so many things that we learned from other programming languages. Like the reason it's so much better than C is not because the people who made it were so much smarter than the people who made C, but because it was made so much later and with so much more knowledge in mind. And
and I think maybe the interesting question is more like when, right? Are we like do we see a better version of Rust, or like a successor to Rust in 5 years from now, in 20 years from now, in 50 years from now? I'm not sure. Right? If C to Rust is something to go by, then it's going to be quite some time. But if we expect that like language, like programming language research is accelerating, then maybe it's much shorter. I'm not sure. Like I don't know what the half-life of a programming language is.
It's probably a bit shorter now, just because like the field is like exploded in popularity so much. Like there's just
that's true.
So much more. Like there's so many more new programming languages popping up. What feels like every week.
Yeah, but that alone is not sufficient, right?
Because
it could also be that you hit a point of diminishing returns where the research into programming languages can't make them that much better. So that's like it's a highly unpredictable, I think, trajectory here.
Yeah, like it just kind of like. Takes time for people to like use Rust and have ideas, and like because like you said, it's only through adding async to Rust that we thought of improvements in other areas of Rust. So it just I wanted to, and this is a bit of a change of subject, but I wanted to get your take on AI. I know this is like
get my take
yeah,
on AI.
I know this is a big topic, but like I wanted
This is
to.
a big topic.
How do you feel about like? Okay, let me narrow it down a little bit. How do you use AI?
So I think my answer is different now than it was 2 months ago.
Yeah.
So I'd say that I use AI in the sense of like ChatGPT, like LLMs in the form of chat, for things like I want to figure out like how this obscure ffmpeg option works on the command line. Like shit that's really hard to search for and is poorly documented and like spread across a bunch of forums around the web. And also for things like figuring out like how much should I charge if I were to do a sponsored segment in a video in the category of videos that I make. I don't know how to answer that question. It's not obvious how to find that information. And it's sort of based on like market research that I don't know how to do. And so for a bunch of things like that, where I need to talk to like an entity that has a broad swath of knowledge that it can combine, I find it pretty useful.
More useful than Google, you would say?
Yes, that's partially because Google has only gotten worse.
Yeah, that's true. Yeah,
but I do genuinely think it lets you search an aggregate in a way that Google doesn't really let you do.
Yeah, that's
like
fair.
if I'm searching for something where part of the answer is on this page and part of the answer is on that page and part of the answer on this page, it lets me find the combined answer in a way that searching and clicking is pretty annoying.
Yeah.
You just need to have a healthy dose of skepticism to what it tells you.
Oh yeah.
Like it will just make up a command line argument to FFmpeg that doesn't exist, right? But as long as you know how to like guide it and you can do research based, like you use it more of like it's almost like someone who knows a bunch of stuff but is also prone to lying about things they're unsure about. So you treat it as like they can help guide you, and then sometimes they just tell you something that's bullshit. But it's still mostly useful.
Yeah.
So I've used it for that for a while. It's only fairly recently that I've started using it for more like agentic coding type stuff. And there, you know, I did my first experience of that on stream. And that was, I'd say, a mixed experience. Like I had to do a lot of guidance to make it not trip over itself. And at the end, I think I was like, this didn't save me time.
Yeah.
It didn't cost me time either. Like I do think it was like, it ended up being about the speed of me when I was there to guide it. But at that point, like it's just like, do I prefer typing more keys or do I prefer guiding someone else to do the work? And there, you know, I felt a little frustrated with the experience because I was like, I don't mind putting in this amount of effort to guiding someone, but I would like it to be a person who then remembers that experience and now is better as a result. That's not the case with the agentic AI. You have to teach it over and over and over again, and it just goes into the empty void. I think since then, I've tried to use it very aggressively just to like as exposure therapy to myself to figure out what it's good at and what it isn't. And what I've found is that there are some things where I think it is a genuine time saver for me. And I think that sort of, let's break it down to roughly 3 areas. One of them is interacting with well-known APIs. So this can be things like SDKs in particular languages. Like if you wanted to interact with, I don't know, the AWS SDK for S3 in Rust, like it will spit out great code from the beginning because there are so many examples of the right code. It will probably even write code that's better than what you thought about because it knows about more of the traps that people have solved elsewhere. So for that, really good. Same thing with like, you want to write some Rust code that interfaces with the YouTube API. Well, there is no YouTube API crate. There's in fact basically no crate for interacting with any Google API, but enough people have written enough code to interact with this API that it just generates like the code the users request and hyper and whatnot to do the right thing with all the APIs. Like great for anything that's like very common code. The second thing I found it useful for is starting to write documentation. It's not good at writing the documentation that's going to be the final form, but it can be really useful for like, generate me a bunch of documentation and ask me for each thing, which things I want to prioritize, which things I want to highlight, and read the code for the whole thing to figure out what's important to highlight here. It can be surprisingly good at like distilling down a good like first draft. And then in that first draft, it will have written too many words. It will say some things that are inaccurate. It like you will have to proofread it and alter it and trim it down. But it is, I think, faster than starting from scratch. Same thing goes with generating a bunch of test cases. Like if I write some fairly hairy code, I can usually tell it, write me a bunch of test cases for this API. And I can even tell it like, don't look at the implementation, only look at the API and the documentation. Now generate like basically behavior-driven development, right? Like write me a bunch of tests that look like how you would expect this library to work based on what you can read. And then I look at the thing it wrote and I go, I understand why my documentation needs to be better. This test is good, but also a bunch of the tests are useless. But for that kind of like bootstrapping work that requires reading a bunch of stuff, I found it to be really useful.
I like the example of like, just using AI to determine how understandable is this to someone else. Like, if you have like your own documentation or like your own code and like you ask it to generate something on top of that, then sure, it might still do something completely off base just because it's AI, but it's still like a good just,
Yeah, and I think I've actually been positively surprised at how rarely it does like genuinely just bullshit. Like it doesn't usually just generate like garbage. It usually generates something that's like 80% intelligent, right? Like something I can work from and shape into something that's useful. And then I think the third category is like semi-mechanical transformations. So these are things where I couldn't trivially search replace. I couldn't like write a sed grep awk Perl script to do this replacement. Maybe I couldn't even write it with semgrep. Like it's like slightly more involved than that. Things like I have an example actually from today where I had a bunch of documentation written where I wanted to replace all the headers with sentence case instead of title case for the headers. So instead of like being, quick brown fox with the Q, B, and F all capitalized, I wanted the Q capitalized, but not the B and F.
Yeah.
Doing this with the search replace is super annoying. There are some ways in which you can make it easy, but like, especially it gets hairy when you have things like some of the words are acronyms and the acronyms should remain uppercase, even though they're not the first word. There's a bunch of that stuff where like tossing this at the AI, it does it beautifully. And if I had to go through and do it manually, it would take a bunch of time.
Yeah.
And there are other examples. Like I had a shell script I'd written for like packaging up some stuff into a zip file that needed to match the like structure that was needed by some external tool I was integrating a plugin with. And it was like a shell script that had grown at that point to like maybe 500 lines of bash. And I just told it, port this to Python. And it did.
Yeah.
It worked first time, no changes needed. And it was because like this is a fairly mechanical transformation. It doesn't have to be creative. And it's seen example of this a million times. And so there I find that it can be a huge time saver.
Absolutely.
But I think those are like the three categories. Anything that's like, make intelligent big changes to this code, I find that I have to be really hands-on with it to get it to do the right thing.
You basically have to code in English at that point. And it's just like...
or I need to write a very detailed plan for it to follow. And that can be useful because... So maybe there actually is a fourth category, which is sometimes I have something else that I need to do that's not at the computer. Like this can be things like... I'm like baking bread, so I need to run over and do a bunch of bread things and then come back to the computer.
You do it a lot.
And then come back. Every now and again. Like I'm baking bread today, for example. So like actually sometimes, right? Or like I'm in meetings most of the day, but I also have some programming thing I want to get done. And so I'm okay with having an agent that like spins and does a bunch of things slowly and inefficiently, but in between meetings I'll check in and it'll be like, write like a paragraph of guiding it on this and that and this and that and reviewing what it did, and then leave it to run again.
Yeah.
And so it ends up taking like a day to do a task that would have taken me an hour, but I didn't have an hour. And so that was still better than it not getting done. So that can be useful, but it tends to be like it's like not time efficient, but it is time like multiplexing efficient.
Yeah, I get what you mean. I'll reply to that soon. I'll catch up in chat real quick. Unpronounceable said, I think the biggest areas that Rust could improve on is to let the user more closely interact with the compiler, like Zig's CompGen, for example. That would require someone to actually make that language, which is a bunch of time investment. I don't know Zig's CompGen. Maybe you do, John. I'm curious what ways you feel like you should...
This is compile time reflection, which I would love to have more of in Rust, and we just don't. And as someone hints at in chat here, like there was an effort to basically build this that got wound up in a bunch of like really unfortunate community mess.
Oh boy.
That resulted in the person who's working on it basically saying, I'm not doing this anymore.
Oh boy.
And as a result, I think that set that effort back quite significantly. It makes me really sad. I think compile time reflection is like one of those things that would be a huge boon to Rust. And I think it's possible. We just need like a set of people to drive that effort forward, because it is highly non-trivial to get it right. And you really don't want to standardize something that's going to come back to bite you later.
Of course, yeah.
But it is something that Rust is definitely lacking at the moment. Like the sort of compile time work you can do through procedural macros and declarative macros is like and const generics. That's like the extent to which you have compile time reflection, and that's insufficient. Like you really need access to types for some of these things, and that's what compile time reflection would give you. So agree that it's needed. Don't know what the future looks like for it.
Is there like a simple example of when you would use that in a way that you currently can't? I realize because this is like complicated stuff, there might not be a simple example, but just in case there's like a...
you could imagine things like a macro that you can only call on types that implement a given trait, and this is checked at compile time.
Okay, so basically just... In short, a type-aware macro, a macro that's not just like a code generator basically, but something that can like actually do something with that can like know about what kind of fields and structs and types it's operating on basically. That makes sense.
Yeah, and you can do some of this by sort of hacking around it, right? So you can write in the example I gave. You could have your macro generate some code, like a function that takes a reference to the type that the derive is on, where it also requires that the bound is that type implements that trait, and so that would fail to compile, but it's all like indirect. It doesn't let you introspect the type. Like imagine you wanted to write a macro that you pass a type to, not a type definition, just the name of a type, and it can enumerate the fields of that type. There is no way to write that today.
Yeah, that's true, yeah.
The only way you can do it is if the macro gets to run on the type itself, like on the declaration of the type. It gets to walk the struct definition. And so that's the kind of stuff that compile time reflection would give you.
Yeah. You basically have to do like some hacky stuff with like a derive macro or something. Like the derive macros are the closest thing we have, where you do have like a little bit of the type definition, so like you have to like derive it on that type. But so basically like a derive macro that doesn't have to be like associated with a specific type.
That's an example. I think there are a bunch of other use cases for this kind of stuff that goes
that's an example,
beyond just like the derives that can be placed elsewhere. But yes, that's the general idea.
Okay. Another use of the few effective uses of AI is to brainstorm designs, ask about data structures rarely used, or algorithms you might not have considered. Yeah, like because like we talked earlier about like how useful it can be to like be in the office and be surrounded with different ideas, and if you're like if you are by yourself, then having like pseudo colleague who's like maybe not like as nearly as smart or as dynamic as like a real person, but who like, you know, can present different ideas to you in a way that's not like, you know, you specifically going looking for them, can be useful.
Yeah, I can find it useful for brainstorming, but usually it has to be directed in a way. So if I just tell it like, what do you think of this idea? It will always agree with me. It tends to be really enthusiastic that I did the smartest thing that's possible, and that this is like wildly insightful of me, no matter how stupid what I said was.
That's true,
right?
yeah.
So I tend to have to say, can you give me a couple of different possible decisions here and what you see as the trade-offs? And then it can be useful, but it's usually in the form of like, it might spark some ideas in me rather than it coming up with a good idea itself. At least that's usually not the case. It will sometimes highlight like, oh, I hadn't thought of doing it this way, but that's a little more rare. What this question sort of suggests to me though is also the slight variant on this, which is when you use it to explore an area you don't know much about. Like, let's say you wanted to learn more about audio generation, right? And you wanted to know like the WAV file format and what is the definition of brown noise and how do you encode noise into WAV files. Like, let's say that's what you wanted to learn about. Well, you could easily just have a conversation with like an LLM about this and fairly quickly get like a rough working understanding of that technology or technology stack. So for that kind of stuff, it can be useful because it's like faster than looking up a tutorial or 3 online.
Absolutely.
And reading a bunch of different Wikipedia articles. At the same time, you run the risk of being misinformed, and so you have to double check everything you read. So whether that saves you time is a little hard to say.
Baum says, I actually hope that doesn't happen, referring to like the metaprogramming thing, because of visibility. I don't like that part of the new C++ reflection as well. It is a good point. Like, you do have to use all of these things like with caution, because it is really easy to write code that's like, you know, just magical and opaque and like, you know, basically do the Ruby thing of just writing high-level code that is kind of like, you know, does things behind the scenes. Like, I think the point of this type of like, you know, metaprogramming should never be to like, you know, do things behind the scenes, but more to just kind of like either automate some kind of boilerplate or just kind of like
although like in a way, if you think about it, macros can already do this, right? Macros can already generate code that like does whatever it wants. So I actually think if you end up giving type information to the macros, you end up with the macros having to do less hacky stuff because they can actually be tailored to the types.
Yeah.
Like today, they're forced to do some pretty nasty stuff that shouldn't be necessary.
Yeah.
You know, things like privacy, you could always have be part of the rules for compile time reflection.
And I think Baum's point here, if I'm allowed to paraphrase, is basically I'm scared of metaprogramming becoming easier because it will lead to people doing it more in bad ways, and I do get that, but I think
I'm not convinced it would become easier. I think it would actually become harder because now you also need to deal with type information.
But it's like, I think especially in a language like Rust that's already like, you know, kind of niche and like, you know, built for like, you know, complex and unusual challenges, it makes sense to have like something that makes it easy or makes it like easier to write nice code basically. And it's like just another tool that you have, and you basically have to be mindful no matter what if you're writing Rust, because it's like
it also means that you end up with macros that are slightly less error prone. Like currently they can be pretty error prone because they don't have this information and need to pull a bunch of other tricks instead.
Well, someone outside your crate would not have access to your private fields anyway. Like it wouldn't just be like a crate coming in with its like, you know, metaprogramming, like, you know, doing stuff to all of your structs. Like, it would still be something that you call explicitly, I would assume. Like, it wouldn't just be something that's like, you know, oh, you pull in a library and suddenly all of your structs in your app have like different behavior or something.
Oh yeah, for what it's worth, I don't think Rust compile time reflection would look like the C++ one. Like it would not give you arbitrary information to all the types. Like
does
it
it
would
do that?
only give if you were in a different crate, you would only have access to the public information about those types. So that like I don't think they would break hygiene essentially. By giving compile time reflection. You mentioned Loom test interleaving. Does that include checking simultaneous writes?
I'm sorry, I'll just interrupt for a quick moment. Frankie, or anyone, please ask questions. Anything that's on your mind, anything you want to know about, absolutely, please ask questions. Sorry, go ahead, John.
No, you're fine. So what Loom actually does is it runs all of the threads it knows about until the next synchronization point, which is basically the next time you access an atomic in any way. And then it sort of forks essentially the threads and runs one world in which one happens before the other and another world where the first happens before the second. And then it does that for like all possible interleavings of all possible operations. So it doesn't really check things like simultaneous writes. It just makes it so that every possible interleaving that can happen will happen. That also means that they run a lot slower because it has to run a lot of these possible worlds.
It's exponential too, right?
So you usually need to, so you basically need to write specialized tests for Loom that can execute in like reasonable time given exhaustive checking. There's also something called Shuttle, which is a crate, I think written by some Amazon folks, that's essentially Loom but randomized instead of exhaustive, which lets you run bigger test cases because you don't actually have to exhaustively test them. But what you lose is that they're not exhaustively tested, so you might miss error cases.
So your tests might be flaky because of that, basically. But like if they do fail, then that's like likely an issue.
Yeah, failures of these tests should mean that you have a bug. So they shouldn't really be flaky. They should just, like with Shuttle, you might just have to run them for a very long time because they're randomized. So it becomes more like a fuzzer, if you will.
I thought
Loom,
you
which is
basically
more
just
like a
would like
model
run it
checker.
a few times and like, you know, just eventually like, you know, just basically like not be exhaustive about it, but just run like a few different seasons and just kind of like only basically it might take you a few CI runs to see that there's something wrong. I thought is what you meant.
Well, I mean, it depends on the guarantees you want. It's the
That's
same thing
true.
with a fuzzer, right? You could run your fuzzer like 4 times for a minute each, or you could run it continuously day and night until it finds a problem.
That's true,
And realistically, you just want to run it as much as you can to increase the likelihood that you find a problem.
Comes down.
I don't think you can really detect UB. For example, the Loom unsafe cell is a completely different API. I think it mostly detects deadlocks and logic bugs. It can detect undefined behavior in the sense that if you have asserts for things that should not be possible because it would violate, it would basically mean you've hit undefined behavior, then you basically run Loom until it panics. Same way you would run something like a fuzzer. But no, it does not have an understanding of the Rust memory model in the same way that Miri does, for example. So it will not tell you that you hit undefined behavior. It will just tell you, it will just ensure that every possible interleaving will happen. And then it's up to you to make sure that you have the requisite assertions and panics that will make it visible when something bad happened.
It comes down to general good taste anyway. Code is mainly about communication with humans, so you need to focus on that in all cases. Yes, of course, then you get into, like, you know, different people have different opinions about what makes, like, good code and clean code and readable code, but in terms of, like, you know, metaprogramming and stuff like that, I do, like, thinking about, like, you know, both, like, will I still know what this means in 6 months, and, like, will other people understand this code can be, like, a decent standard to hold your own code to. But yeah, I didn't know that
Rust
thing about...
specialization. There's a question about my thoughts on Rust specialization, which is like, I would like Rust specialization. I don't know when I'm gonna get it. I've sort of given up on asking because I know there are enough people asking and there are enough people thinking about how to make it happen. But yes, I would love to have it. One day we will.
Someone already told me, but I kind of forgot what exactly is specialization in Rust gonna entail again. Because it definitely sounds familiar, but I'm
So specialization would be something like, imagine that you implement, imagine you have impl t clone for vec of t, and then you want to write impl clone for vec u8, and you want to write a specialized version of clone specifically for vec u8.
Right.
That would be specialization.
Yeah, got it. And you can't do that now because those two implementations would conflict, right?
Exactly. They would be currently there would be overlapping. With specialization, the compiler would realize that one is more specific than the other, and therefore there's no ambiguity in calling. Like the reason they're rejected right now is because any overlapping impl is rejected because they don't want the compiler to ever have ambiguity about which impl to use. But in the case of specialization, the argument is there is no ambiguity. You use the specific one, and then it's figuring out that in all possible use cases, which is the hard part.
That makes sense. But so is it
if you're doing regression testing, you can use a fixed seed or seeds in those test runs. That's only kind of true. So seeds they don't fix a particular execution pattern if your code changes. So the problem tends to be that even if you use the same seed, if your code has changed and you now have different synchronization points or different thread spawn points or whatever it might be, that seed no longer leads to the same execution because the synchronization points aren't the same anymore. So usually when you find a bug with these tools, you then want to write a specific test that exercises the pattern that was problematic, so that becomes your regression test.
5G asks, what's the feat of software engineering you find most impressive lately? Something I've been enjoying a lot recently is I've been writing front-end with Svelte. And something really cool they do, like, I don't know how much you know about JavaScript front-end frameworks, John. I don't know how much you do on like the web front-end side.
Relatively little. I've used Svelte a little bit, but not enough that I could talk about it.
So I've always been a big fan of Vue, but the one thing that bothers me about Vue is that its tooling support is kind of like, mid at best. That it's like, its support for TypeScript, its support for linting is like, because it has like that custom template syntax, it needs like a bunch of like custom tooling to support that is, for what it is, good, but compared to something like React, not that great. And so the really smart thing that the Svelte compiler does under the hood is when interacting with TypeScript or ESLint or something, it compiles down Svelte to JSX and then passes that JSX to TypeScript and ESLint. And it basically means there needs to be so much less Svelte-specific tooling because it can just use the React tooling for Svelte, and it's incredibly brilliant. And so despite being a little less convenient than Vue in some ways, I just chose Svelte as the front end for this because it's so incredibly, just a really cool idea. And I'm hoping that Vue will do the same at some point.
Yeah,
so
that's neat.
What's yours?
I think it's hard for me to name like a feat of engineering.
Yeah.
I think, there are some things that are really impressive, but they're on a different scale. Like the Linux kernel is a good example of something that's like wild that exists.
Yeah.
Like truly just insane that is a thing. And I think there's some other ones like Systemd is also wild in a different way. Both in good and bad ways that we have it. I also think it's like as a marvel of engineering that we have computers that mostly work. I'm just like, every time I write software and run into a bug, I'm like a little bit amazed that most of our technology mostly works. When
Absolutely.
It's all just like hacks piled on top of hacks. And so I don't think I can really name like one feat of engineering that is wilder than the others. I just feel like there are lots of marvels of engineering that are like all around us that, like, curl is another example of something that just like it's really cool. it's really cool that we have curl. Like HTTP too. TCP itself is a marvel. The IP stack and the fact that we actually managed to have a narrow waist in the entire internet like infrastructure is also wild. But I feel like it doesn't really answer the question. Like Valgrind is another wild example of software that exists. RR, which lets you do reverse execution of programs, is wild. Git itself, really cool.
Oh yeah. Rust, the borrow checker, Rust async, like it's all the things Rust can do. The things they brought over from high-level programming languages, from functional programming languages, from programming languages that are a lot less efficient than it is, and to compile down to assembly is incredible. Just the things that it can detect at compile time is so wonderful.
I think it's also pretty wild the amount of bandwidth we have crossing the world.
Oh yeah.
Like just the amount of information that goes over these wires is also just mind-boggling engineering, but it's like engineering at a level lower than like computer science in that regard. But just like think about the undersea cables we have, right? Like, okay, I have what is this? This is like a 1 gigabit connection or something, so I can stream like 4K video and it's no problem. The undersea cables carry the traffic between like Europe and the US, right? And they carry that across like billions of people. Just there's so many bits. And the fact that all of this like works and has like okay latency, it's just insane. But yeah, it's a different level of feats of engineering, I think.
I think it's just it also just kind of shows that like I feel like being optimistic is kind of like you if you think about this, you just kind of have to feel a bit optimistic, right? Because it just shows you the things that we as people, as humans, as a society can do, you know, like if we
have Wi-Fi on planes.
It's just so there's like, you know, even if things like sometimes seem like, you know, they're like, you know, insurmountable challenges, or like, you know, things that are like, you know, problems that we face as like a people, I feel like the things that we've achieved so far are like, you know, would seem completely impossible, like, you know, even like 100 years ago or something. And it's like I feel like 50, 100 years from now we're gonna do like a lot more like incredible stuff, and it's like so much of the stuff that's like happening is just kind of like happening behind the scenes, but it's like, you know, enabling like so much cool stuff.
Just take a look at like storage today compared to 20 years ago, 30 years ago, right? Like I can go down the store and buy like a 5 terabit drive, and you're like, that's more storage than existed 30 years ago.
And like you don't even think about how that just unlocks so much more stuff. And like I feel like one of the next big thing is probably going to be like battery technology, and there's definitely going to be like, you know, big developments there. It's going to just change so much to have like, you know, because like right now batteries are such a limiting factor.
I think that's the hope. I think there's an interesting question about whether it's possible. Yeah. But it is the hope. Yeah. Right. But this was also the thought for CPUs, right? That like we had Moore's law for a long time, but we don't anymore. And whether we've hit that part of battery scaling, I don't know yet. But batteries are one of the things where we haven't seen very like exponential growth, at least not for a while. So maybe there still is like a big step function ahead of us that would be really exciting. I just have no idea. But I agree with you that if we see it though, that it makes a huge difference to a lot of tech.
Yeah. But it's also like, you know, sure, Moore's law no longer holds true, but it's like, that doesn't mean we've stopped, like, you know, evolving, and like, computers are still getting more performant, you know, like, just because like CPUs specifically are not evolving in the same way that Moore's law used to define. They're still so, every year we like, you know, things get more performant. It gets easier to like do things that we were struggling to do 10 years ago because we didn't have the performance to do them. So it's
yeah, I think the other thing we see, right, is that even if battery technology, for example, doesn't get better, other technology gets better and reduces the amount of consumption of battery. If you look at things like what's it called? LPCAM2, which is basically RAM sticks that in laptops that connect directly to the CPU to reduce the distance between
Exactly,
the CPU
yeah.
chip and the memory, and therefore reduces the amount of power the CPU needs to output in order to get to memory, which means you save a bunch of battery, and it like doubles battery life. And you're like,
yeah.
battery technology didn't need to change. We just changed how the chips are organized on the board.
And so, like, maybe we find other ways of storing energy, or, like, you know, just ways to reduce energy consumption, which is gonna change everything. And, like, you know, these things, like, all work together. And I think that's why why I just generally like to be optimistic, because there's always so much innovation that happens behind the scenes, and, like, by itself, you know, okay, you move the RAM closer, so, okay, so that by itself doesn't seem too impressive, but if
and then it has all of these, like, spiraling effects.
Exactly.
Yeah.
And yeah, the ocean cables are incredible that we managed to connect. Like
it's just wild. Oh boy. There
is a basic bug whenever you optimize the systems grow to occupy the freed space, but I mean that's the point, right? They grow. There's like new things that come up, new challenges. Like obviously I find that the feature, you know, as we free up space, as we stop dealing with other challenges, we encounter new challenges, because if we didn't, that would be super boring, right? If we basically just made the old challenges easier and didn't fill in the blanks with anything. Oh yeah, OLED is super cool too.
More and more bloat in software, which is part of the like, it is true that software is also kind of getting slower, even though everything else is getting faster. And some of that is because we're getting new features, and some of it is because there's less of a focus on performance. Now the performance is cheaper, and so you get less performance optimization, and so you get more things that are just kind of slow.
But that's especially why I just wanted to, like, get back into Rust, because it's like, you know, I feel like it's so rare these days that you get to really, like, you know, worry in quotes about performance, you know, because, like, you know, in web dev, it's just like there's a genuine trade-off these days between, like, do you want to focus on just being productive, shipping stuff, or do you want to optimize, you know, because optimizing just takes so much longer. And I enjoy optimizing so much, but I didn't get to do it, and so now I'm just, you know, I'm writing Rust, I'm refactoring things over and over to make them more performant, even though I haven't even deployed anything yet, even though it's, like, completely overkill, but I'm just...
But sometimes it's just really fun to write performant things.
It's fun.
Yep. No, I agree.
So just to think about, oh, what if this has like 1 million users? Then how will this scale? You know, it's just enjoyable to do.
Yep. And then inevitably, if you ever get to that point, the bottlenecks are never the ones you thought were the bottlenecks.
Exactly. Yeah. Like but who knows? Like maybe that's just because you solved the other ones already.
It could be. You solved them prematurely, but there's always some other bottleneck.
Of course.
Like every time. Oh boy.
What is a particularly enjoyable project you've worked on recently?
Well, so I think these Rust bindings to NNG have been really fun to write, but they're not done yet. But I'm planning to open source them once I've tested them some more and make sure they actually work.
You said it was like a successor to 0MQ, right?
Yeah. It's written by the same author.
Okay.
So they basically went on to write NanoMessage, and then they went on to write NNG, which is NanoMessage Next Generation. And it's a really cool way. It's a really cool library for doing like a lot of like low-level networking protocols. And I think the Rust bindings are turning out to be pretty cool.
So
I think though.
What?
No, go ahead.
How would you compare 0MQ to something like Kafka? It does a lot less than something like Kafka, right? It's I think it's only
Yeah, I mean, so 0MQ and NanoMessage and NNG are all brokerless. Like they're intended to be just substrates for communication.
Okay.
They are not intended to be like a full queuing system or anything. They intend to build network protocols that you can then build things like Kafka on top of. But what they only implement the sort of network protocol side of things and none of the application logic.
Okay. What's What's leptos again? I've heard of that, but that doesn't. I can't place it right now.
Leptos is like a Rust front-end framework. I haven't used Leptos much at all.
Let me Google it. Leptos. Oh, it's for the web. I mentioned this before. I just would not really use Rust for that because the issue is that you. Like, this is WASM, I'm assuming, and the problem with WASM is that if you interact with the DOM, it's not really going to be faster than TypeScript anyway, because like the WASM to DOM interaction is like very slow. Like you have to use like a DOM bridge, and it's you basically like you cannot directly interact with the DOM from WASM. You have to bridge to the DOM, and it's just a lot of like it's slower than doing it in JavaScript directly, and the alternative is doing like WebGL and just rendering like a completely custom GUI. But then it's like impossible to make it accessible, and I think accessibility is way too important to consider it like a trade-off. So I just wouldn't.
Yeah, I think there's a lot of value in writing WASM things in Rust, but the value lies in building specific components.
Yeah.
Not I think to write your entire front end in Rust.
Not to replace JavaScript, but to like, you know,
yeah,
like we discussed like with
Python. That seems like the wrong path to me.
Like we discussed with Python how there's like, you know, it makes sense to have like certain modules coded in Rust to like have certain, you know, specific units of work be more performant.
Yep.
But to the like front end itself, JavaScript is still like, you know, by far the best choice we have.
Yeah, I don't really think the goal is to like get rid of JavaScript and TypeScript. Like, at least that's not, I don't see that as a goal here. I think it's totally fine to say we continue to write the front ends in that, and then because that's the best suited language for that job.
Exactly. Software gets slower as hardware gets faster because software seems to be built to be good enough on current hardware, which makes sense, you know, like anything that's business oriented will always want to be good enough because like it's simply not profitable to worry about performance beyond what you need, you know? And
I don't think it's even just about profit, right? I think it's also you have to choose where to spend your attention.
Exactly.
And if the software is good enough, you would rather focus on adding the features people want than to dive more into the performance.
Yeah.
So you only really get to the performance when things are feature complete, and then scope creep means that things are never feature complete. And maybe that's part of the problem, that people need to be willing to have software that like doesn't support email, for example, right? There's like an old joke that every software project grows until it eventually supports email. And so there's like some amount of truth to that, but I think part of it is also like, if you're one developer or a team of developers, whatever it might be, you have limited focus time and you need to choose where to spend that effort.
You're right, this is kind of like Java applets, but there's a reason those went away, and I don't think we should, I mean, there is a reason that there's been no language that really has replaced JavaScript, you know, because like, for all the bad, what
about Flash? What about Flash?
Bring back Flash, huh?
Bring back Flash. Or what was the Internet Explorer thing that they had?
Silverlight.
They had Silverlight, but before that they had
ActiveX.
Was it DirectX?
ActiveX.
ActiveX. Yeah. That's the real world.
Yeah.
That was pretty great.
I also have heard of Ergot. What's that? Is that a Rust thing or a messaging library? Is that what you were thinking? Is that what you were talking about?
No. ActiveX was like code you got to run directly in the browser process. It was like a SO you could get the browser to download and execute.
That sounds...
It was terrible. It was a really bad idea. But you could do everything in ActiveX. It was great as an application developer. You had full flexibility to do whatever you wanted in that browser process.
No one would ever take advantage of that.
No. It was never a security problem at all.
No. How was my Rust experience in the latest streams? Honestly, it's just... I missed it. It's just such a good programming language. It's just so nice to... I don't know, like, especially because I hadn't done any kind of recreational programming for like years before that. it's just so nice to just be able to like I really enjoy refactoring. I probably enjoy refactoring too much, so getting to just like, you know, rewrite code over and over until I'm happy with it is so nice. I just enjoy that, like, you know, just make it shorter, make it more efficient, and it's really enjoyable. Oh, I forgot to talk about my take on AI. So I was pretty reluctant to like even try it out because like it's just anything that's so overhyped, I just kind of like automatically stay away from, because if it's just if it's presented as the next big thing that will replace everything and oh my god, you have to get in on this now or else you're a little bozo who's gonna be like left in the dirt, I tune it out. And so I was kind of like forced a little bit by my employer to have a bit more of a look at it, to at least like try it out, you know. And at least at work, like I still don't use like generative AI basically ever because I just don't find it fun. Like you mentioned, it can be like, you know, it can be okay for speed, but it's not really faster, and it's like just a different, less
but
fun.
I think it depends on what you use it for. Like I think there are some things where it genuinely is faster, but you just need to find the right things.
So what I do really like using, at least for work, I like using cursor autocomplete because it's like it's basically, it is of course kind of generative AI, but it's like, you know, behind the tab button. I don't like coding in English, you know. So I like basically the thing cursor tab does that's really useful is it just extrapolates what you might want to write based on the code you've already written. So it's really good for the kind of thing you mentioned, like say like you're doing some kind of search replace that regex just isn't good enough for, then you just do it once and you just tab through the rest of them. It's really useful for that. So just any sort of boilerplate where like you start writing something and it's like a really, really smart autocomplete and it like saves you so much typing. I really enjoy that. And
yeah, I think maybe the mistake I made before I started using it like in anger was I think I assumed slightly less creativity. I assumed the agentic AI was less capable of creativity than it is. Like I have found it to be like I can describe a loosely defined problem and have it actually do something sensible to a much greater degree than I thought. But I've only realized this after forcing myself to do it a bunch and finding the right way to express thoughts to it. But as a result, I feel like there are definitely things where like this is a useful tool in my toolkit now.
I do also use it like when I just have like, you know, something small I want to do, and it's like, you know, basically like with Devin. So like it's a lot simpler to just say, hey Devin, make that change, than for me to like, you know, spin up a branch, make the change, commit, push, make a pull request and all that. It's just a one-line Slack message to like make a simple
although
change.
I have found that the only agent that works well is Claude Code. Like I've tried a couple of different ones now and they're all really bad.
I think Devin
like,
uses Claude.
Really bad.
I think Devin uses Claude on the hood.
Nice. Okay, then that helps.
Which ones have you tried?
So I tried Gemini. I tried the OpenAI like big model. I tried some like local ones. I've tried Claude. I tried GitHub Copilot. I think those are the ones I've tried so far. I've been told I should try Warp Dev, but I haven't tried it yet.
But yeah, I mean, the thing is, I just personally don't enjoy using it, like the whole coding in English. I have used it sometimes, like for bigger refactors, like, you know, what can be really useful is like, you know, if you're doing like an application-wide refactor, then you do it once and you give it like a patch and you like apply this change to like every other instance of this. It's really good at like just extrapolating from something you're giving it.
Yeah, I mean, I think the title case change, for example, is a good example of something where
absolutely.
there's not a patch, except it's just I just describe what I want and it happens.
Yeah. I mean, that's simple enough that you can just describe it, but if it's like, you know, I don't know, like, remember, I think it was like a Tailwind refactor or something, where it was like, you know, one pattern, just a component gets replaced by a Tailwind thing, and I was like, replace all instances of this component with this kind of change, and it's actually pretty smart about it too, yeah.
Yeah, it's true.
Rust was made.
Okay,
because...
I think I'm hitting my the end of my stamina. I know you normally stream long into the night, but I think I'm hitting the end of mine.
That's totally
But
fair.
I'm happy to take like last minute questions, whether from chat or for you, before we or my side wraps up at least. You can keep
totally
going without
fair.
me.
I know you're not as much of a night owl as I am, so I appreciate taking.
I used to be, but now that I have work starting at like 9 in the morning.
Oh boy.
I need to actually sleep at some point.
I do appreciate you taking this time though.
No, of course. I mean, it's a lot of fun. I love talking about this stuff. I need stamina training. Yeah, it's true.
You want to quickly touch
Although,
on the,
to be fair, I do like 8-hour coding streams. It's just that they don't go at this time of day.
Yeah. Yes, the VOD will be available on Twitch and on YouTube. You want to quickly touch on the with AI to check the work, what is the need for Rust? I think AI code review can only go so far. I think it is useful for catching some basic issues, but it can't do nearly as much like static, like I don't think it's possible for anything to do the kind of checking that, you know, a proper like type checker, for instance, can do, because there's just so many things it has to know about, so many things it has to do and look for, and it's just it would just be really expensive computationally to do that, or like for a person to look through all of that. And the thing about static checking is you can trust it, whereas AI, you always have to like check its work.
Yeah, I think where it can be useful is things like, there are some things where it's kind of hard to write a linter for some things, but you can pretty easily take an LLM, point it at a bunch of code style guidelines, and then tell it, go look at this MR and tell me ways in which it is non-conformant with this spec, in ways that, like, it's not trivial to write an actual programmatic linter for. It would be pretty annoying. So there's some of that, like style type things that it could enforce. There are also some things where, like, especially for more junior developers, you could tell it about, it can be pretty good at recognizing how one change violates things that have been stated elsewhere, like in other documentation it has been given or read, for example. So you can sort of do more global reviews for things, for what looks like a local change but has global implications. But I do think you still need a fair amount of like human review as well, even just for identifying ways in which it's not this change that's the problem. It's like the fact that you didn't also change this system is like something that there's not an obvious indicator that it was even something to check. And that's where I think you can easily run into trouble with these things.
I think another way I would phrase that is that AI is, really good at doing 90% of the work. So just like getting something like basically 90% of the way done, so you have to put like the finishing touches on it. And the issue is with the kind of I touched on this earlier, how like using static checking or like Rust is, the big benefit is that there's so many things you don't have to think about now, because like the you can just like check them off in your mind, know that if you look at a piece of code, certain invariants will hold true, because it's like you know that if this is of that type, then that there can't be multiple mutable borrowers to something. You know that there's certain things about the memory model will hold true, and if you have like a lint for something, you know that that's going to be true everywhere. But if you only have an AI checking it, then you still need to be on the lookout for it. You still need to make sure that it's not something the person or the AI missed. it's less likely, but if you need it to be a guarantee, then you still need to think about it.
Yeah, I mean, I think humans are fallible in this way
Of course.
too, but I do think that like these kinds of nuances are the kinds of things that tend to slip through the cracks when AI tries to write and review code as well. Someone else in chat, let's see. Non-null from self as reference to din trait, where the trait is restricted to send sync. Is it fine to do an unsafe impl of send and sync of non-null of din trait on a new type wrapper?
And even just passing a borrow of a din like that? Oh, you
yeah,
can.
it gets coerced. It get coerced to a pointer and then turned into a non-null. I think you're fine to implement. To implement both send and sync for your wrapper type. It's not immediately obvious that this wrapper type is safe in the first place because you still need to uphold the lifetime guarantee around the reference, right? So this reference has some lifetime. And so when you turn it into a pointer, you're effectively erasing the lifetime. But you would still need to guarantee when dereferencing this pointer that that lifetime is not expired. But on the send sync part specifically, I think you're fine.
Armand has asked about your thoughts on the materialize DB.
So materialize is sort of a bigger topic. Like I think way back when I made like a huge post on Hacker News, so sort of a reply to a comment about materialize and sort of trying to explain how they differ. The biggest take between materialize and the database I built for my research is basically that materialize aims for strong consistency rather than eventual consistency. And as a result, it gives you, I don't want to say better ergonomics, but more like easier to work with semantics. But what it gives up is a lot of performance for reads, right? Which is the traditional trade-off for eventual versus strong consistency, is that now your reads need to synchronize, and so they are way slower. And so it's like materialize gives you things like transactions, whereas Noria, my project, did not. But as a result, your reads were also like orders of magnitude faster. And so the question is, which of these do you prefer? So they are kind of different rather than being directly comparable. They are both incremental view maintenance systems, but that's sort of where the similarity ends.
Is your PhD project, right?
Yeah. It was called Noria, and it's since been turned into a startup that actually built it as a database product. So the database product is called ReadySet. And it's basically it's a thing you put in front of your database so that all of the queries will read from this, sort of a read through cache, if you will. So all your queries hit that, and if they're supported by that, then you get incremental view maintenance, you get automatic caching basically for all your queries. And it's automatic caching not just in that they're fast, but also in that the cache is automatically updated and invalidated. As you don't need to manage it. You can just take your existing application code and just, instead of having the DB connect string be your backend database, it's ReadySet instead, and now it's just faster. So it's pretty magical.
How does it work that they took your PhD project and made a startup out of it? Did you get anything for that, or is it like you?
I'm one of the founders.
Oh, okay.
No, so
okay.
I'm involved with the company as well.
I thought like some other startup, which is like, thank you.
yeah, no. Although my PhD thesis and all my research is fully public, right? So there's nothing private about that. But this is the one that I'm actually involved with.
Cool.
And so I'm not working at the company, but I'm basically like interacting with the CEO and many of the engineers on a regular basis to like help them continue to develop the thing. So they've built some really cool stuff on top of that research.
I love that. Cool.
And now they have support for both the MySQL and Postgres wire protocols. So if you have an application that's written against either, you can just like replace the connection string, and now your thing is just way faster, and it's super cool.
But yeah, it's kind of like what we looked at with left right, where it's like, if you're using it for what it's supposed to be for, you're like, well, that's so much better. Why doesn't everything do it like that? But then you get to the trade-offs, and it's like, okay, well, it just depends on what you're doing. Like that's why there's reasons for why different things do it differently, because you have different use cases.
It's true. I was just gonna try to dig up the link so I could send it to there. Very unpredictable URL. Readyset.io.
100 times the scale, 0 code changes. Hell yeah.
Yeah.
Is that really how it works?
It is pretty wild, actually. Like this sort of how my research panned out too. Like a lot of the experiments in the thesis and in the paper is like, I took this application, I run it through this, and now like the applications are genuinely 100 times faster. Like it is really cool.
But I imagine that's like only if you're already only using a subset of like Postgres and MySQL, right?
Yeah, I mean, it depends on the queries, right? Like, it doesn't make write queries faster, for example.
Okay.
It only makes read queries faster. And it needs to be read queries that are possible to support in an incremental way. So there are a bunch of caveats to it. But it turns out that quite a lot of queries do match this pattern, and as a result are optimizable in this way.
Yeah. Because you mentioned that like it doesn't have transactions, right? Or does this have
It does not. Yeah, it does not have transactions. Or so the way it ends, because this is a pass-through system. If you do a transaction, you basically end up hitting the backend database rather than the cache.
Okay.
So they're supported. It's just that they would be slow the same way normal.
Okay, I got it. So this is like, it actually has like no downsides then.
That's the idea, right? Is that it truly just makes things faster.
Hell yeah. That's awesome.
It's very satisfying.
I love seeing you so happy about something you've made.
I know, right? I think it's funny though, like in my PhD thesis, there's one graph that's like the one I'm the most happy about. Let me see if I can dig it up.
I think it's I have it here, I think this here, right? Oh no, it's not on your GitHub. Where is it?
MIT-PDOS.
Right. Slash what? Sorry.
MIT-PDOS. But I think I have the.
Yeah, there it is. There.
That. Yeah.
We were actually looking at this a little while ago.
It's not that graph. So this is the graph that everyone points to because it's cool and it makes things faster. The actual graph I'm thinking about is. There's a link to my thesis there, or I put it in chat as well.
I'll open that up.
And it is in the evaluation section near the end. And it's a graph that has a bunch of purple in it.
You like purple?
Yeah, so if you just like kind of scroll down. No, keep going.
This one?
No, it does not look like a normal line graph.
Oh, okay. We'll find it.
It looks all wonky.
Well, we're past the evaluation section now.
Oh no, then it's okay. Then we scrolled past it. Oh, maybe it was the first one you showed me actually. Right.
Back to the first one. This one.
Well, there's a delay in what I see. No, further up.
I'll wait a bit longer to make sure that.
No, it's not that one.
Okay, this one here.
Because that's a normal line graph. That's a CDF. Oh, that one. Yeah. Okay. This one.
What does that mean?
Took me so long. It took me so long to make, because this is like, read the description of the figure, and then try to parse out what this is.
All right, time after start and page latency. 128 seconds after start, so after 1 second the page latency goes down. I guess it has to like it's like populating the cache or something, and then
Exactly. So over time, more and more of the queries end up being in cache because the way this is set up is like there's a website that looks kind of like Lobsters or Reddit or Hacker News, right? And people access random pages and look at the comments of random pages. But over time, more and more of those pages will be in cache, and so you end up hitting them more. Now, the thing that's funky about this is that this is showing you a CDF of the distributions of times of page latency per segment of time after start.
Yeah.
So in the time between 0 and 1 seconds, the colored bands are the quantiles of time that requests end up taking.
Okay.
So you can tell from this, for example, that the median amount of time it took for a request to finish in the first second was like 8 milliseconds. You can also see that the 90th percentile is about 100 milliseconds. So it packs a CDF into the color bands of each segment of time.
Sorry, what's the CDF?
Including the mean. A CDF is a cumulative distribution function. It's basically the quantiles. So 25th percentile, 50th percentile, 90th percentile, but it's a full graph.
So you came up with your own kind of graph
to show
for
you
this, basically.
Yes, exactly. And so it shows you a time variant plot of quantiles that is logarithmic in x and y. This turned out to be exactly the visualization I wanted, and it was such a pain to get. But it ended up not just very compact, but also pretty. And so this is the graph I think about when I think about my thesis and all the graphs. It's not the one anyone else thinks about.
I love that.
Because anyone else just thinks about the other graph that shows things being 100x faster.
Did you come up with like this graph entirely yourself, or was there like some...
Yeah, I was like, what do I want to show? Well, I want to show this. And it took me a bunch of iterations to get to it. Why does the 99 to max block grow after 2 seconds? It's because you... I think it's described in the document later, but I believe it's because you have to start doing evictions. And evictions slow down the time of the requests that end up missing.
So there's basically more statistical outliers, basically.
It's actually, you don't get more, but the outliers you get are slower.
Oh,
because they have to compete with
Yeah, of course, because
evictions.
it's like, yeah, of course, yeah, makes sense.
So between 1 and 2, you're at the sweet spot where all of the requests you can put in memory still fit in memory, so you don't need to do any evictions.
So as with left-right, like one of the biggest costs is memory usage, of course, I'm assuming.
Yeah. I mean, this is a process that uses all the memory you can give it.
Right. Okay, that makes sense. Yeah.
But the intent is that it doesn't swap. So if it starts to swap, then it like
defeats the purpose.
The performance of using the cache drops significantly.
Yeah.
And so it basically says, tell me how much memory I'm allowed to use, and I will use that much memory, and then it will evict as you start to get to more.
It's interesting because
Can also recommend reading both this thesis and the accompanying paper if you're more curious about the details here.
It's also like it ties back into the whole, like, you know, you don't realize how certain like improvements will bring about other like developments, because like you look at this and you find yourself thinking, wow, why has no one else done this before? The reason is because we didn't have as much RAM before, you know, like RAM.
Yeah.
For the longest time, RAM was not really a resource to play around, but like something that you wanted to consume as little as possible of. But when you start getting into servers with terabytes of RAM, then it's like suddenly you can do something like that.
Yep.
And it's just cool how. So why does the green line go up like that here? Is that like
so
artifact
this is,
or?
No. So this is specifically how these plots work. So this is a latency throughput plot, or a throughput latency plot.
Yeah.
So in throughput latency plots, what you do is the x-axis is how much load, how many requests per second you offer to the system, and the y-axis is the latency you observe for requests. And the idea is, at some point, you're offering more requests to the system than the system is able to handle.
Okay.
And so at that point, the latency shoots through the roof. And so what you look at for any given system is how far right can you push the system before it falls over. And so every system will exhibit a graph that looks like a hockey stick. So these are often referred to as hockey stick graphs of like, you are measuring for when can they no longer keep up and load, and that's when the latency goes vertical.
And is it like about like with this, where the point is be about on the same level of the y-axis as this is then, I would assume.
So the y-axis is infinite here. Like the latency goes to infinity.
Because it just gets like bottlenecked completely.
Yeah, because
like,
you're offering more requests than the system can handle, so the queue grows very quickly to infinity.
Yeah, that makes sense.
And the system effectively runs out of memory and crashes.
Because this isn't like a burst. This is like sustained.
Sustained, yes.
Yeah, okay, that makes sense.
And so what you basically compare when you compare these plots is you don't actually compare the y value. You compare the y value on the left side of the graph.
Yeah.
Because that tells you at low offered load what is the latency like, and then you compare the offset to the vertical line.
Got it. Thank you for explaining. This is super cool.
It is really fun,
and it is what makes it cool, because like I'm gonna be honest, generally like data structures, graphs, and all that, it's just kind of like pretty in one ear out the other, but like to hear how much you enjoyed making it and like hear you're passionate about it is what makes it like interesting,
Well, the fun thing with graphs is like you can tell a lot of interesting stuff with a graph if you just think through how to make it. And a lot of people don't. They just plot things and just toss it on screen, and then they tend to not be that useful. But if you really think about how to make a graph that tells a story, like there's a really good book called The Visual Display of Quantitative Data. And it's a very boring title for a book, but it's a very good book. It's written by Edward Tufte. And it's essentially an exploration of good and bad ways through history of visualizing data. And it's just like, it's a book with a series of graphs, some of which are really good and some of which are really misleading. And then talking about the ways in which they're good and bad.
That's cool.
I love graphs. I'm a big graph guy.
I love that you love graphs.
Who doesn't love graphs? Who doesn't love graphs? How can
I personally, I'm not a visual person whatsoever. Like I look at a graph, I look at a diagram, and my brain turns off. Like text is infinitely infinitely easier for me to understand than like.
So picture worth 1,000 words.
No,
not so
like
much?
a word is worth 1,000 pictures for me.
I see. Nice. I get it.
I don't know whether you know what aphantasia is, but I have it. Like when I close my eyes, I see nothing. So I'm like
Yeah, no, visuals. I have the same.
Really? Okay.
Yeah.
But visuals
I'm
still
terrible at like internal visualization. Really bad at it.
Okay. I'm also like, I don't know. Are you terrible at design too? Because I'm horrible at design.
I think I'm like mediocre at design. I don't think I'm quite terrible. But I think it also depends who you ask.
Yeah,
if you ask people who know design well, I'm sure they would say I'm terrible. But I don't think I'm as bad. Like I can see things that have terrible design and identify that they're terrible.
But knowing how to fix them, that's the hard part.
I know, right? How much does this relate to virtual and memory paging? Not very much, actually. So the tricky part in Noria was not so much building the cache as it was figuring out how to update the cache proactively. So one of the like main trick in Noria is this thing called incremental view maintenance, where the idea is very basically, imagine you have a system that counts the number of upvotes on an article. And imagine that some article currently has 100,000 upvotes. And so you store that in your cache. You have like article foo has 10,000 upvotes, 100,000 upvotes. One vote comes in. What does your system do? So a traditional caching system would update the database by inserting another row into the votes table, and then it would either delete the cache entry because it's invalidated now because you changed the article, or it would recount the votes and update the cache with the value of the updated count. But both of those are problematic. So if you delete it from the cache, what ends up happening is the next time some request comes and looks at the cache, finds nothing. It has to go to the database and then count all the votes again. If you have multiple things that all hit the cache at the same time, they all find it missing, they all go to the database, and the database count it basically has to count to 100,001 like 40 times at the same time, which is stupid. The other option is when you detect that you're invalidating the cache, you count to 100,001 once, and you insert that value, and you never actually invalidate the cache. You just update it in place. But you still had to count to 100,001. What Noria will do is it basically implements the entire SQL execution engine inside of the cache. So when you do a write to the votes table, it realizes that there's a field that is in one of the cache entries that is a count of the votes. It realizes that I know the previous count, I know that there's one new one, and so I understand addition, and so I will just increment the number by 1 without having to count all the previous ones. And so this is the incremental part of view maintenance. And so Noria implements that, and that is the hard part, or one part of the hard part.
Any thoughts on DBSP? How does it compare to Noria's model?
DBSP is kind of similar, but also a little different. So DBSP is it sort of tries to take the derivative of queries to basically compute a query that tells you what changed in between. So given a set of changes to a set of base tables, it gives you a query that you can execute on the change to the base tables, and it tells you about the changes to the output of the result set. And you execute those over time, and now you have incremental view maintenance. It's really cool. It was built after I developed Noria. It actually ends up working quite similar to how Noria works. Like if you like squint at the algorithms, they end up doing similar things. But I haven't seen it be like, one of the big things that Noria has is what's known as partial materialization, which is the ability to say, let's say you have this cache of vote counts. Imagine that you want to have it so that you have the vote counts for some of the articles, but not all of them. So you don't have a cached vote count for every article in your database. You only have the cached counts for the most popular articles, for example, the ones that have actually been requested. This is what my thesis talks about when it talks about partial materialization. DBSP doesn't have a mechanism like that. And as a result, you end up having to materialize the complete output of your queries, and you can't easily say, I want to only materialize the output for these parameters of the input. Or you just have to execute lots of queries that are very similar, and you don't get to share any of the execution like machinery between them. And so it ends up being kind of inefficient if you have lots of queries that are the same. So those are some of the ways in which they differ. But it is really cool work. Mm-hmm. And it is very closely related.
I'm curious in general what gave you the motivation to do like a PhD, especially because you're generally more of a practical person. I'm curious what made you pursue one.
I think it was a combination of, it felt like a sort of default thing to do after a master's, maybe. Like, oh, I did a master's, why don't I do a PhD? It's more of things I think are interesting. Mm-hmm. I think
so you did it immediately after your master's?
I did it immediately after, mm-hmm. Yeah. Part of it is also, as like a 12-year-old, I was like, I'm going to go to MIT. And I applied to MIT 4 times before mm-hmm. getting in. And so, like, I applied straight out of high school. I applied after a year of bachelor's at a different university. I applied after my bachelor's, and then I applied at the end of my master's. Mm-hmm. And I got in at the end of my master's. And so I was like, well, I'm going to do it. And so the option was do it as a PhD. So then I do it as a PhD. But I don't think it was like I'm going to do this because I specifically think that the outcome of a PhD is important to me. Mm-hmm. It was more that I just wanted to keep working on interesting things, and it felt like the freedom you get to explore and research in academia appealed to me. Mm-hmm. I think over the course of being in academia for so long, I had maybe more of the realization of, I want to build things that get used. Mm-hmm. I want to build things whose purpose it is to be used, rather than to be like studied and built upon. And that's one of the reasons I'm not in academia anymore, is because I felt like there was too much willingness to say all that matters is I ran it on my laptop and I wrote a paper.
Yeah.
I wanted something more than that, and I think industry and open source gives me more an ability to like build something whose aim is for it to be used widely.
That makes a lot of sense. Yeah. But yeah, I mean, I feel like you found like a good way to combine the two by making like your PhD project something that
I think so.
Yeah.
I mean, it's still, you know, it's a company that's still trying to like, you know, it's still a startup. We'll see whether it succeeds or fails at the end, but like, I really think it's a great idea.
Yeah.
And I really think it matters to a bunch of applications. And the question is just, how do you make it be like a production ready tool that makes a difference to companies that just kind of want a plug and play experience? Because getting to that from a research prototype is a long and arduous journey, and that's basically what the company's doing.
Absolutely, yeah. Stratum said, my system is a foundational architecture for intelligence augmentation. A unified framework that can be applied to any existing digital system to make it smarter and more collaborative. Interesting. Is this something you're building or with the company? So, if you want to quickly explain it, I'm curious, like, just to like as a short summary, if there even is a possibility for a short summary, how is it possible that you're like going from that you're basically not scaling with the load at all until you're suddenly hitting the limit? Like, how is it possible that the amount of load is not affecting your throughput at all?
Well, that's not terribly surprising, really. It's just because the system doesn't build up any queues because it's not in capacity.
Okay.
So it's actually like the reason that line is flat is because of left-right. Like that's actually the reason, which is I built the system in such a way that like reads do not contend with each other. Like I have as many request handling threads as there are cores on the machine.
Yeah.
And every thread that wants to do a read does a single hash map lookup and then serializes the result. That's all it does. So they are perfectly concurrent with each other. And so as a result, until the system cannot keep up with load, there is nothing that causes latency to increase. And then when it can no longer keep up with load, well, then you can't keep up with load, so the line goes vertical.
I guess the better question to ask then is like, why do readers in something like MySQL get in each other's way? Like, why is it because they have to consider the fact that a write could be happening?
There are so many ways. There's so many ways in which MySQL is not optimized for performance.
Okay.
So many ways. But one of them is it is not generally built to have the reader handle threads not contend with each other. Because MySQL is not trying to be an eventual consistency system, right? MySQL is trying to be a database that provides you with some kind of consistency guarantees. And the way you do that is you have coordination and synchronization between reads and writes, between different tables. And so as a result, it cannot scale in that way. As you do more concurrent reads, those reads need to synchronize with each other.
Yeah.
Right? They need to synchronize with each other so that they can give those consistency guarantees. And that slows them down. It means that the more reads you have, the more they slow down. So it's an exponential slowdown, if you will. It's not quite exponential, but like it's a self-reinforcing slowdown, and that's how you end up with these graphs that are not flat.
So it's a combination of like, you know, less than optimal design and just trade-offs.
Yeah, it's a little bit of both.
That makes sense.
I'm sure they could make MySQL behave better on this kind of graph, but that's also not the focus.
I just read Mystic's comment.
Yeah, that's funny. It's true. With optimistic concurrency and MVCC, reads don't need to synchronize much. They don't need to synchronize much, but they do need to synchronize. And that's all it takes.
Yeah.
It's the same thing with like, Noria did not work with reader-writer locks because even though reader-writer locks, like when you take the read lock, you supposedly don't need to synchronize. The reality is the way the read side of a reader-writer lock is implemented is that you take a mutex for a very short period of time.
Oh.
And then you release the mutex and then you hold the read lock. But that means that there is a short period of time where your CPU needs to synchronize on a memory address with all the other CPUs to guarantee you have exclusive access. That synchronization is all it takes for this line not to be horizontal. And so MVCC and optimistic reads require even more synchronization than that. And as a result, you end up with this contention. The reason why the lines are so far apart, which is part of what exaggerates the view here, is just the fact that MySQL doesn't cache. So it falls over way sooner because it has to do compute for every request, which Noria does not need to do. It genuinely just has to do a hash map lookup.
So there's basically ways it could be like, more like this or something, like more hit like the peak a bit like later, but like it would never be flat just because like the reads would always in some way have to contend with each other.
I think if it were more optimized, what it would actually be is it would be more like an L shape, but it would still have the horizontal, it would still have the vertical at the same point.
Yeah. Oh, really?
The only way to move the vertical is to do less work. So they could probably move the vertical slightly by reducing the amount of contention, but realistically, what actually changes is the curve towards the contention.
Okay, that makes sense. Yeah, because it's just the queue just starts filling up, like you said, and at that point it just gets completely overloaded and it can't.
Yeah, like at that point you can't keep up anyway. But the question is more, how do you behave when your system gets close to capacity? Is the only thing you can affect.
But I mean, if you basically get this to be more flat, then like you said, you would also move the vertical a little bit, just because like your overall throughput would be a bit more, so you would be able to, like the queue would fill up at a higher number,
you
basically.
Exactly. So you would be able to push the vertical slightly further right, but probably not by a lot.
Yeah. Version logs don't need the atomic write of the read-write mutex, although they are technically not safe in the C memory model. A different system than Noria has a different perf trade-offs. Yeah. Which is there, since we're talking trade-offs, is there any use case where you would not use Noria or ReadySet? Like, is there something where you would say this is like not good for?
Yeah, I mean, if you primarily do transactions, if you primarily do writes, if you can't handle, like if your application can't tolerate eventual consistency, like if you're writing like a bank ledger, that you wouldn't use this.
Also, write-heavy workloads, I would assume, like same as left-right. If you're writing more than you're reading,
it basically has the same trade-offs as left-right.
Okay.
It's very similar, like because they're built for the same purpose, right? Which is very read-heavy workloads that are tolerant of eventual consistency.
But the cool thing is, I feel like that's most workloads, right? I feel like, at least in my experience, I feel like most workloads are read-heavy because like you almost, like unless you're like logging something, you're like almost always gonna read more than you write.
Yeah, I mean, that's basically the motivation for making Noria in the first place, right? Was this observation that most applications work this way. Version lock is the reader does atomic read of version, then reads data, then rechecks version after read.
It's kind of like a reverse left-right then. Or if the version changed after the read, do they reread, or what do they do if the version changes after the read?
That becomes the question, right? Because if the reader ever has a loop, like if it needs to, this is like optimistic read, right? If you read but your optimistic read was a failure because the version changed, then now you need to do it again. And it's that now you have to do it again. It's that part that then screws you in the latency curve here. because then you
Oh, you
start
fall
contending.
back to a normal lock, but then you would still like, you know, then you would still end up locking and like with.
Well, which, like, to be clear, optimistic locking and using like version locks here are totally useful. Like, they are a way to improve the performance of the system here, but they don't eliminate the need to contend.
Yeah.
Right? They reduce the cost of not contending when it's not necessary. But the reality is, the way the system was set up was that you generate random page loads. Most of those pages are reads, but some of those pages are writes. So it's not a system with reads only. And as you increase the throughput, you're also increasing the rate at which writes happen. And so you don't get to have a system that just like scales infinitely as long as everything is reads. This was intended to be a benchmark that tries to emulate realistic user scaling behavior. And so there's more about that in the evaluation section of both the thesis and the paper that talks more about the exact evaluation approach here.
And like the big thing is really like, are you okay with the concept of eventual consistency, that like, you know, you are maybe
that
like
ends
some
up being
readers
a
are
big
reading
part
out
of
of
it
date data, and like, are you okay with
Yep.
like working around that?
Yeah,
And
because
like, yeah.
Noria does not try to protect you against this, right? It doesn't have things like version locks.
Yeah.
It will give you stale results sometimes, but that is the chosen trade-off.
Yeah. Which for instance, like, a chat is totally fine, because like when basically like, you know, user connects, register like however you do it, you like register some kind of like listener for events, and then you read from the state. So like whatever happens after is like, you know, it's okay if they read stale state, because they're gonna get a notification that's gonna get them back up to date. So it's it just depends on whether you have a system where it's okay that like because like it doesn't matter if like, you know, a user joins and they're seeing like, you know, the name of a group be like something else for like a second and then it updates.
Yeah.
You know, that's totally fine.
Yep. And I think, you know, that was sort of the observation, that most applications don't care.
Yeah.
Most applications, eventual consistency is totally fine, and you're totally willing to make that trade-off.
The thing that a library for it has to do, like, you know, something like this, is to make it as easy as possible to implement the actual consistency part, to like, you know,
Yep.
update the data and bring it like up to date after the fact.
Yep.
OS
Yeah, I mean, you
unfair
can
lock.
think of it as that kind of like progressive lock, except that it doesn't have a fallback. Like, it's not intending to have a fallback. It specifically says, if you happen to read an old version, you read an old version. There's no recovery mechanism. There's no fallback to something that guarantees that it's always strong consistency. It's simply, you just read what you read.
I think Armalis was replying to Alpine here, because like what Alpine was saying kind of sounds like that it's like an incremental lock basically.
Yeah, the version lock is kind of similar. They're at least related in the sense that they're both kind of progressive / optimistic locking mechanisms. Do you think eventual consistency is a fundamental trade-off when using partial materialization? No, I don't think so. I think you could implement strongly consistent partial materialization. It's just, I don't know if anyone has built that system. And it, like, partial materialization is fairly complicated to build. And so it's like hard to add to a system after the fact. So I don't know how you would take materialize, for example, which is strongly consistent data flow, and try to add partial materialization to it. I think you would have a hard time. Cool. I think that's my cue.
Yeah.
Now the chat is has released the lock.
The read guard has been dropped.
That's right. I'm ready to move to the next epoch.
No, but really, like, thank you so much for being here, for taking the time.
No, this was a pleasure.
Chat.
Thanks for having me.
And thank you for left, right, and all that. I will continue using it, and I'll send some PRs your way for like little improvements that things that have
sounds
come
perfect.
up.
I hope this was useful and interesting to both you and to chat.
It was super interesting and useful and fun. Most of all, fun.
All right. Thanks. See you all. Have a good night.
Thank you so much for being here, John. Have a great rest of your night, and yeah, bye-bye.
Bye.
I shall... Hold on, let me... In fact, since it is rather late already, I will also stop now. But friends, thank you so much for being here for this. Thank you for spending time with John, with me. Thank you for making all of this possible. And I hope you have an amazing rest of your weekend. I will be back tomorrow, and I will chat with you more. Straight up, I would love to hear more about like your hexagonal consciousness thing. It was a bit too in-depth for this conversation, but we can definitely chat more about it tomorrow. Thank you all again so much for your company. If you haven't yet, please do leave a follow. I will be back tomorrow working more on this thing, which is a little chat server written in Rust, using left-right, using a bunch of cool stuff. Just a little for fun project that I've been working on to get to do some Rust again. And check out some of these links if you want to stay in touch until then, and I will see you again tomorrow. If you have an idea for a raid, let me know. And thank you for your company. Well, let's see who's streaming. Who is streaming? Yeah, please do Stratum. Thank you all so much again for your company, friends, and I hope you have a lovely rest of your weekend. And bye-bye for now.